Okay. Does anyone have any lingering questions from yesterday? Anything I wanted to talk about as far as what we covered?
Transit gateway peering. Top of my head, that is between two regions.
Right, yeah, it has to actually be between two transit gateways in two different regions.
Yeah.
Yeah, you can't peer with a transit gateway in the same region.
Right. Because it's a regional device, so.
Sorry, my headset decided to mute itself. Oddly enough, obviously, remember we said before, you can create multiple transit gateways in a region and just have them route to each other, right? But you can't peer them together. And, honestly, you don't really need to, so. Okay, so here we are, we're on containers. By the way, this does assume that you have some background knowledge with containers, but luckily there are some slides in here that will talk a little bit about what containers are. You may remember that when I talked to them just briefly, that this is process isolation, right? So containers are not virtual machines, and they look like they have an operating system running inside of them. They don't. They're not running a kernel, right? So containers are really nothing more than a jailed, isolated process that's been packaged in a certain way. So we're going to talk about containers, but a lot of this focus is actually on container orchestration, not containerization itself. But let's get into it. First of all, is anybody using containers at NTX?
I think we are, but from at least from what I'm familiar with, there's not a lot of it. And I don't know if we have anything yet in production.
I think it depends on the projects. I think in MavQ, they use it for sure. And then there are some other older projects, I think, where it's used as well. But yeah, it's project specific.
Okay. So just to mention this, and this is not a bombastic prediction, but containers are slowly eating like the world by storm, which I got to tell you, I kind of fought it for years. And then I did my first deployment in 2017 and then 2018. And then, now they're guesstimating that based on surveys, that's why I say guesstimating, that about 65% of the world's infrastructure is running on containers as far as like the big tech apps. So, this is a big change. And so containerization is pretty much going to be the de facto deployment model here pretty soon. And it's not necessarily like the container orchestrators themselves, of which Kubernetes is pretty much the only kind of like, private side choice. Because the rest of them have pretty much disappeared, including Docker Swarm, which also orchestrates Kubernetes. So it gets really confusing. But just know that this is actually going to be the de facto deployment method for the next 5 years. Like pretty much everyone's headed in this direction until the next new disruptive technology comes along. Because remember, when virtual machines came back out in 2001, that blew everybody's mind. Containers came out in 2014, right? So it's still blowing people's minds. And so it hasn't even hit really like large mainstream adoption, but it's getting there very quickly. So then that begs the question, what are the benefits basically of using containerized applications? I'm just going to answer this for you, just so you know, because this is kind of a marketing question. The answer is all of the above, right? And so whenever because when you containerize an application, you standardize its packaging format. So whether it's Java, Ruby, Python, doesn't matter what the code is, you're basically standardizing the packaging format into a known standardized interface. Then what happens, like think of it like a zip file that has like a little extra meta information in it. If you take that zip file, you can, as long as you can unzip that file, you have the unzip software, you can run that application anywhere because everything you need to run it is inside of it, including the JVM, the Python interpreter, like whatever it is that you need in order to run the thing. So this makes it really portable. It also makes it somewhat environmentally independent. Now I say somewhat because you can't run a Windows container on a Linux host. So if you have a precompiled binary that's precompiled for Windows, you can't run it on a Linux host. And you can't run a Linux precompiled binary on a Windows host. Now, if it's Java, by the way, and the JVM, you have the JVM for Windows and whatnot in there, that's a different thing. But by the way, most of us aren't sticking multiple JVMs inside of a container. So it's usually actually purpose built for the operating system in question. So there's a lot of portability in that. But just so you know, you are still limited by the operating system and the processor architecture. If you make a Go binary and it's compiled for x86 64, you're not going to run that on ARM. So containers solve a lot of the environmental problems, but there's a small percentage of them that you can't get around. Okay. You also can reduce operational costs because you're no longer copying operating systems. Think about this. If all you need is the application and you're not, because the virtual machine model has us copying the operating system every time we want to run an application. We're no longer doing that with containers. Now we're just copying the application. Don't worry, I have a visual on this. So you're going to see it and visualize. We're going to talk about these things again, just giving you a little bit of a preview. Reduce management overhead. Okay, so first of all, I just got to tell you, that's a lie. I don't even know why that's there. It's increased management overhead. You just went from a bunch of large, chunky virtual machines, and you're right, your security footprint is smaller because you don't have an operating system, right? Now you don't have to manage the operating system, but here's the problem is that with containers, you typically deploy more of them. So you usually increase your management overhead. So I kind of understand where they're headed with this, but this is not technically accurate. Because if this was technically accurate, we wouldn't ask you to use a container orchestrator, right? You wouldn't need orchestration if it was easier to deploy them. You don't see anyone going, hey, do you have a virtual machine orchestrator? We're comfortable deploying virtual machines. So anyway, we'll talk more about that. They do actually scale better. Because imagine with the same horsepower is only dedicated to an application. It's not dedicated to an application and a virtual machine. So now as you duplicate the scale of your application, you're not duplicating the consumption of virtual machine horsepower, right? You don't have to worry about the operating system being duplicated every single time. So scalability is actually way better. The only one I have a potential issue with is reduced management overhead. There's actually usually more complexity with containers, but don't worry, that's what we have container orchestration for. So we'll talk about that. Okay, so we're going to talk about containers, and there is actually going to be a lab. So lab's already warmed up and queued. So you're actually going to deploy an application onto the Elastic Kubernetes service, which we're going to talk about what that is. So here's the modules, is that we're going to talk about ECS and EKS, which are the two core services that deploy and orchestrate containers. They both have a deployment mode where it's based on EC2 or it's based on hidden EC2. That's called Fargate, right? I have an issue with whoever named it Fargate. They should have just called it serverless. Someone was being fancy and decided to call it Fargate. I don't know why they just didn't call it serverless, but they didn't. So when you see the words Fargate, what that actually means is serverless. Just replace that with serverless. That's all it means. So we're going to talk about, obviously the project background, containers themselves, container hosting and orchestration on AWS, and we're going to talk about the specific services, and then we're going to do our little lab. So, the background here is that they're using Docker for about 10% of their applications, and they want to make sure that everybody knows what the architectural choices are between ECS and EKS. So they want to model container architecture within 2 weeks. Pretty standard. Now, the app deployment manager, the operations manager, both the operations managers speaking twice here actually, and the application manager, all have questions, right? We have it, like, for example, on the left-hand side with the application manager, it says we have an acquisition that's going to bring Kubernetes into our project requirements. What does that look like? We're getting, top on the application deployment manager, we're getting too many custom deployment requests for virtual machines environments, right? We need to simplify portability of applications. How do we do it, right? On the right-hand side, it says we're spending too much time managing container solutions. We need a more managed solution to optimize our operational engagement around running containers, right? And then we're spinning up a lot of containers, which is the one on the bottom. What are our different hosting options and how can we reduce our operational costs? So containers, hosting containers, ECS and EKS, that's what we're going to cover. And inadvertently, by the way, we're going to cover something called the ECR, or Elastic Container Registry. This is where containers are hosted inside AWS. This is where you can pull down the container images. Sorry, not where containers are hosted, where the container images are hosted. Very specific language there. So let's talk about containers. So they want containers. That's basically what they're saying, is that we want to simplify portability. We think this is an answer. What do we do? Well, it's actually pretty straightforward, is that You build a container image, and for most of us, this is going to be Docker, right? Docker is like Kleenex, by the way. When you say pass a Kleenex, you're saying just give me a tissue, right? That's really what we're saying. Kleenex is a brand. Docker is a brand. Now, it just so happens that Docker, the company, like, were the ones who broke the ground on containerization. They're the ones who said, you know what? We're going to make it easier for people to jail their processes. We're going to call it Docker. And then they did something very gracious, and they gave it to the world. They made a bunch of standards, standardized the interfaces, got a bunch of people together with like them and CoreOS, actually, which CoreOS is now owned by Red Hat. They actually got them together and said, we're going to standardize everything before this blows up, so that as it goes crazy, everybody's going to adhere to the same standards, right? And for the most part, they were remarkably successful. So while Docker is no longer the king in a sense of enterprise container orchestration, they are definitely the king of containers. So distinction, they're not the king of container orchestration, but they are the king of containers. So when you build a container image, obviously you can actually do your own standardized testing and deployment, because remember, you're just running an application in there. So everything that's in there, your CI/CD pipelines just need a few tweaks to use containers. That's it. It's not a massive change. You might need to get into the container in order to actually run your test now. But honestly, if you're exposing your application properly, you're just now hitting the container instead of hitting the application directly. You can run this anywhere with the caveats that I threw out. The OS has to match and the processor architecture has to match. But don't worry, like Docker and the associated kind of Docker repositories / registries, they usually handle that for you. If you're downloading from a system that's a Linux x86 box, it grabs a Linux x86 container for you. If you go to a Linux ARM box, it grabs a Linux ARM container for you. And I'll show you like where and how that is like tagged and what that looks like. And then scaling, just so you know, containerization handles everything except for scaling. So when we say Docker, we're talking about everything that packages that whole thing up. If we're talking about scaling, deploying, healing in production at scale, we're talking about Kubernetes. Like in the industry, right? We're talking about Kubernetes. Kubernetes is the premier de facto container orchestrator. And by the way, this does show up on the exam, right? Just so you know. It's not just me waxing poetical about the industry for you. But containerization handles everything of the first three: scaling rapidly and handling scale, self-deployment, recovery, self-healing, all that stuff. That's all done by a container orchestrator. In this case, it would be Kubernetes or ECS, which is the container service. So EKS and ECS are our offerings. Conceptually, here's something to really consider when we talk about containers. So in our old model, what would happen is that we would basically have virtual machine operating systems, and we would repeat this again and again and again for each application that we had. So this part right here would get duplicated every time. Problem with that: licensing, cost, performance, attack surface. I mean, the benefits are numerous because it's isolated and it's independent, right? But then the drawbacks are also numerous because it's isolated and it's independent. So now you've got multiple large footprint entities that you have to manage. What they do with containers is they do this same thing, but this goes away and they replace it with a Docker engine, also known as a container engine, or a container runtime, or a container supervisor. Notice that you still need an operating system in both locations. Now, I know I just referred to a hypervisor as an operating system because it is an operating system. It's talking to hardware, it has a kernel. It just so happens that a hypervisor is an operating system specialized for hosting virtual machines. By the way, there is no equivalent hypervisor yet for Docker. CoreOS is probably the closest. So app 1, app 2, and app 3 are now all self-contained in their own independent little isolation layers. And so what would make this drawing really perfect is if they did this. These containers are and the processes that are inside of them are now jailed into their own memory, user space, own kernel spaces. They are now jailed just like virtual machines are jailed, right? So same thing. Brad, in reference to your earlier question, I wish they had called it Farscape or Stargate. Instead, they combined it and called it Fargate. Maybe they were fans of both. I have no idea. So, but this is what changed, is that we're now getting rid of this operating system layer. This is gone, right? Now we still require an operating system, but again, as long as you have the translation software, you can now run the containers that you want. No container software means no containers, right? So you still need a container software. So a container orchestrator just has a general rule of thumb, like Kubernetes has to run the container software for the containers. And there's lots of different containerization software. There's not just Docker. There could be Builder, there could be Moby, there could be Rocket. There are other containerization softwares out there. It's just that Docker is by far the most popular, by far. So now, if you want to roll your own containers, because you may remember, and I think someone posted it, there are 34 ways to run containers in AWS. If you want to look that up, just look up there's an article called 17 ways to run containers on AWS, part 1. And then he got so much feedback on it that he wrote a part 2. So there are 34 ways, including ECS and EKS, that you can run Docker containers on AWS. Now, let's be serious. There's only 2 places you're going to want to run it, which is either in ECS, EKS, or you could roll your own Kubernetes solution, or you could use, Red Hat's OpenShift, which is a first-class citizen on AWS. So here you've got containers on EC2, right? And notice that you are responsible for starting these virtual machines. So this is very much a highly unmanaged way for you to do this all yourself, right? So you can do this if you want to. Then we end up with Docker. I would like everybody to note that the mascot for Docker is a whale. That's going to come up as relevant later. Technically relevant, like not just Michael telling you history, technically relevant. Anyway, Docker is a basically, virtualization containerization standard, right? For how to basically virtualize processes. Very light. Docker basically took all their standards and gave them out to the CNCF. If you're not familiar with the CNCF and you work in the tech industry, you should get familiar with the CNCF. This is the Cloud Native Computing Foundation. Any piece of software that they graduate, like they endorse, is pretty much like the industry standard for that particular piece of software. So this is made up of Amazon, Google, everybody. When you build containers, this then allows you, by the way, to take these containers and deploy them in an isolated manner, right, on anything that has the Docker software on there. Now, if you're running Kubernetes, by the way, Kubernetes takes care of downloading the software relevant for your container, doing various what they call container runtime interfaces. So here, we've got multiple containers that are all isolated from each other. One thing that I take issue with is that this little purple thing down here and this little gray thing down here, as far as bins and lives being shared among containers, no, that's not how it happens. Everything is in the container. So the container is completely independent. So there'll be a copy of all the bins and lives. They're not going to share them across containers because the containers could be running on different hosts. So don't be fooled by that diagram. Everything you need to independently run a container, the application inside of a container, is in the container. So if you need a third-party library like ImageMagick, because you're still using stuff from the 90s, it's kind of a joke actually, maybe the 2000s, it'll be inside the container, right? So you're going to have multiple copies of the ImageMagick library inside the container. You're not going to use shared libraries.
Could this be implying that app 2, A, B, C are actually all the same app altogether in one container?
It shouldn't be, because just so you know, in a container, you only run one application container. Like you typically won't run multiple applications inside of a container. You typically only want one process or one supervised process inside of a container. So my thought, Brad, was that they were saying, well, app 2A, B, and C are all the same container, which they are, because it's 2A and 2B and 2C. So they're just instances of the same container. But it is a little misleading that they make you think that somehow they're sharing the same binaries and libraries. They're not. They're all independent. And we'll talk about how, by the way, multi-level products let's say you have a web app server, or a recommender that has 3 different processes to it, how those get bundled and separated, right? Yeah, Mohit, like pods, which is why pods, by the way, groups of whales are called pods, which is why this is now technically relevant later. It's Kubernetes uses a deployment model called pods, and they do that because the mascot for Docker is a whale. So, but we'll talk about pods here in a second. We're not there yet. Okay, so the way Docker works is that you're going to take a Docker file, and that Docker file is going to have syntax that says, I want you to pull this Java file from my local directory, and I want you to put it in the container. I then want you to pull all this stuff from, let's say, Spring Boot, and I want you to put this in the container. And then I want you to download this configuration file, and I want you to put this in the container. This is what a Docker file does, is a Docker file gives you imperative instructions, not declarative. It gives you procedural instructions. Do this, do this, do this, and then do this. That's what a Docker file does. This is how a container image is created, is with a Docker file. And we're going to look at a Docker file, so don't worry. So what happens is that your Docker file gets committed to repo, and then AWS code build can actually build the container, generate an artifact called the container image, and then it sticks the container image inside of this registry, right? Which is called the Elastic Container Registry. So the artifact that's generated from here is actually put in as an image, which a container image is basically an immutable copy of your Docker container. So the image is the source of how you just spin off and run multiple containers, right? So if you have version 10 of your Java app inside the container registry, and you want to run 10 of them, Kubernetes will go grab a copy of the image and spin up 10 copies of the image for you. So like in this case with EC2, it's actually got to go back to the registry, and it's going to download multiple copies of the file and run them on all the hosts that are available to run it. So if you ask for 10 instances of this app, it's going to download 10 copies, usually on 10 different hosts, and set them up for you. Excuse me. So remember, this still requires an operating system. So even if it's serverless, somebody has an operating system running somewhere. Okay. So we're going to dive in more into that, but just remember, Docker files are what create container images. All right. Now, what makes up a container image? So interesting, right? So what's interesting is that each layer of a snap is like a snapshot of a file system, right? So every stack, by the way, starts with a base file system. Now it says kernel there, right? Which is kind of interesting because it's not really a kernel, right? It creates kind of like, in a sense, it leverages the host kernel to run the bootfs file system, right? So then it's going to start a base image, which is then going to start additional, like we added Emacs, for example, right? Then we added Apache. And then what happens is it adds a thin disposable read-write layer. So unless you add a disk to this container, all it's going to get is that disposable read-write layer on top, which means when this container is stopped or it crashes, you're going to lose all your data. Now, immediately, some of you might be saying, well, Michael, when would we ever run a database inside of a container? You just attach a disk to it. What they call a volume, basically. You attach a volume to it. So this is a little bit misleading because it's actually not running a full kernel. It's using the host kernel, right, to do this. But it is actually mounting a file system. And so this base image, which, by the way, Alpine is the flavor of Linux, right? When it mounts this, it's actually just mounting the binaries, right? It's just mounting the binaries. The binaries themselves are actually running against the host kernel. So note, by the way, that almost all Docker images use some kind of base image as their root. If you don't want to use a base image, you can use a special image called Scratch to do that. That has shown, I had a question about that on the last exam about Scratch. If you just want to run a Docker file and you don't want to use a base image, what do you use? You just use Scratch. That's what they call it. It says it's from scratch. So notice that every time you add an instruction to your Docker file and it changes the file system in the container, it's going to add a layer. Why does it do this? Because it'll download the layers independently. So if you go to the next version of your container and the only thing you've changed is this particular layer, let's say this, you changed it, you updated Apache to the latest version, what will happen is it will only download the Apache layer down to your local system. Think of it like Git. When you have a primary GitHub repository and you clone it onto your local file system, all it's going to do is it's going to download changes when you do a pull, right? That's it. It's not going to re-download the whole repository. Why would you do that? All you need is the changed file. So the reason Docker does these layerings is that it's only going to, and this one doesn't count because this one's not even going to be there. But when you download or update a Docker image, it's just going to download the changes. That's it. So this is done this way on purpose to make it efficient for you to download and update container images without having to re-download the whole thing. Now, let me be upfront about this. Most container images are somewhere between 30 megabytes and maybe 300 or 400 megabytes if they're not Windows. If they're Windows-based images, they tend to be a gig or 1.9 gigs, it's like 1 to 2 gigs. And it's a vast difference. Containerization was originally written for Linux, not for Windows. So that's what's happening. So they're updating it. Windows containerization is catching up quickly, but it's a little behind compared to everything else. But this all works the same. Okay, so in a traditional Docker architecture, what ends up happening is that you have what's called a Docker daemon. And this Docker daemon is handling both the running of containers and the downloading of images. And it's going to pull it from a location called Docker Hub. Docker Hub is the most popular Docker repository in the world. Let me show you what this looks like. So if we go to hub.docker.com, assuming that Michael can type, what happens is that if I search for Redis, because I'm really loving my in-memory databases, you'll see here that there's, and I usually use verified official images. You'll see that there's the Redis official image right here, and it doesn't have a username next to it. It just says Redis, right? It doesn't say Bitnami Redis or CircleCI Redis. This means that this is an official vendor image from the vendor. If I run Docker pull on my command line and I've got Docker running, it'll pull down the Redis image, much like a git clone will do. And it'll clone the image to my system from the Docker, from hub.docker.com, from this repository that we're looking at right here. Now notice that there's a bunch of possible tags that I could pull from. Latest, which is not recommended that you use latest, just so you know. Here's one based on Alpine. So this is Redis based on Alpine. This is, and that's Alpine 3.5, General Alpine, et cetera, et cetera. But let's say I'm like, you know what, I really would like to see the Windows images, right? What can happen is that you can come down here and say, I want to filter tags. Sorry, I clicked on the wrong place. And let's say I want the Windows images. Notice that these are almost 5 gigs in size. If I go back to the Alpine image, right? It's 10 megs in size. Yeah. So just so you know, Windows containerization is going to take a year or two to catch up probably to where the Linux containerization is, because Windows just got containerization in 2019. It's been around since 2014. Okay. It also operates very differently on a Windows box. So just be aware that most of what we're talking about is Linux based. So hub.docker.com is the registry where you go and download your favorite software. So if you're like, hey, you know what? I really love Postgres. This is where you grab it from. The reason this is important is that when we're running things like Docker build, Docker pull, and Docker run, because we're running it on our local system, those are downloading images from a Docker registry. We saw a Docker registry earlier because we saw it with ECR here. ECR is also a registry, but ECR is a private registry that runs on Amazon. Hub.docker.com is a public registry that they offer. In general, most enterprises will not run and pull images off of hub.docker.com. It's just too much of a security risk. And there have been hacks. Like Tesla got hacked one time. They didn't lose anything important because they downloaded a vendor image off of docker.com. They've gotten way better at this. This was years and years ago, but it doesn't matter. Most people, if they do pull off of docker.com, will scan those images to make sure they're sanitized, right? Make sure there's nothing malicious inside of them. But I gotta tell you, that's really hard to do. It actually is really hard to sanitize images at a deep level if there was like some kind of like rootkit, but you can look at the files and fingerprint them. So ECR public and ECR public gallery are public versions of the private ECR repositories that you can use. So, you know, Amazon's starting to host their own images. And the reason for this is that Docker's starting to charge money for accessing those public images. So just be aware, right? So most enterprises are going to run their own Docker repository, their own image repository. They're going to manage it themselves. Amazon does offer their own images that they've sanitized that they will put inside your public repository for you, right? So just know that you actually have to have a registry in order to use Docker, in order to use containers. You have to have it. It can be private, but you need either a public or a private one for it to work, okay? Here's an example Docker file of how you could build an image. So in this particular case, this is the sourcing, which means if I go look for Python 3.7 Alpine, wow, that looks pretty bad, actually. Hold on. If I go look for Python colon 3.7 dash Alpine, it'll be out there under hub.docker.com. So if I don't specify a URL in front of that Python, it's going to go out to hub.docker.com. It's going to pull its file from there. If I put a URL in front of that Python, it's going to go grab it from whatever registry I've specified. Now, notice I'm setting my working directory here under workdir. I am then copying every file that I have where I'm running this Docker file, like I'm running the Docker build command, and I'm copying it into the app directory inside the container. Remember, /app is inside the container image that I'm building. So I'm now copying every file I have in this directory into /app. So if that's a Java file or config files or whatever, it's all going in. And then I'm actually going to run pip install, and I'm going to look at the requirements txt, which I probably copied up here. And so I'm going to pip install, which is going to have Python go and grab, you know, all the packages and dependencies that it needs. And then I'm going to make sure that the container has a hole in it so it can listen on port 80 to receive traffic and right on port 80. And then I'm going to use Gunicorn to actually run my app. And it's going to listen on port 80. So when you expose a port, and you, by the way, I can expose multiple ports. I could expose 443. I could expose other ports. What you're doing is you're basically saying to the container shell that wraps around the application, I want you to receive traffic on those ports. If you don't expose the port, nobody can get past the container into the process. So you always have to expose a port if you want it to, like, listen on the network. Notice, by the way, that the application has to be listening and it has to be exposed. Right? Notice that? Now, by default, most of the time, you don't have to tell an application to listen. Right? When you start an application, it already has a port number defined somewhere in there. Like if we started Apache, you want to say, hey, Apache, go ahead and listen on 18.443. It's already in the configuration for Apache, like a web server, right? Or Nginx. But notice here, we're actually declaring it so you can actually see it called out. Now, this is all part of the official Docker documentation. So if you go look up Docker build, you'll find all of the directives that you can put inside of a Docker file.
So port 80 and 443 are typically, you know, HTTP/HTTPS. Any particular reason you'd have 80 exposed?
Usually people expose 80 so they can redirect it to 443.
Gotcha. Yeah.
Yeah, I would say nowadays, no, don't use 80.
Right.
Right. Or if you want customer convenience because there's legacy people accessing, right, or they forget to type HTTPS, just have it redirect to 443. That's the only reason I use it.
Well, why don't you do that on the load balancer if you're using a load balancer rather than have the Docker?
You are absolutely correct, Brad. Yeah. Much rather. Best practice would be put it on the load balancer, not on the app.
But you could redirect it, you're saying, in the app 80 to 443.
Yeah. But honestly, at an enterprise level, I would do what you're suggesting. Just
Yeah.
do it at the load balancer. I wouldn't even put that load on the systems, right? I just make the load balancer do it. There's a bunch of things like the CMD command, by the way, I didn't really talk about that. The CMD command is what the container is going to run when it started. So when you do a Docker run and you specify an image, this is what it's going to run at the very last step. Almost all Docker files end with either what's called a CMD command, with command instruction, or what's called an entry point command, which is just an executable instruction. So they almost always end with run this. Otherwise, the container is not going to do anything, and you have to specify your command on the command line. So, okay, here. So just to say this, Docker forces you to version everything because every time you want to update a container image, you have to increment the version. So if you do not specify a version, it's going to give it the version latest, which is horrible. Because remember, in software, both in software engineering and in infrastructure engineering, we don't want to just randomly increment our dependencies, do we? Right? And if you put latest, it's going to increment and you're going to have no control over what version you get. So just know that you typically want to tag your containers with specific versions. This is version 1 of my app. This is version 2 of my app. And every time you deploy or build a new container image, you're going to increment the version, right? And Kubernetes, for example, will do that for you, just as an FYI. Versions are specified using tags, which is what I just said. Tags are specified using the Docker tag command, or when you run a build, you can actually do a -t and specify the tag. Latest is the default value. There are some companies out there that won't even let you download the latest tag from their repositories. Elasticsearch is a good example. If you try to pull latest off of their Docker hub, they won't let you do that. They force you to specify a version because so many people have been bitten by latest. It actually should be disabled, frankly. Okay.
So Michael, so you're saying that when we compile from GitHub or so, we always put a version for the latest code, right?
Well, remember, you're going to compile your application and then you're going to compile a container.
Right. So what about the Apache? Like, I'm trying to understand what goes on with the Apache version versus like my application version.
So ideally, they would match. So when you compile your app, let's say it's version 24 or 1.0.3, you should build your container, your Docker container, and that Docker container should have the exact same tag, version 1.0.3. So you want your tags between your app version and your container versions to match. Otherwise, how are you going to know like what version you're running inside the container?
Right. So the Docker version is actually my application version as well, if I think that way.
In terms of best practices, yes.
Yeah, and I just need to know what Apache version I am working on, right?
Yeah. Yes.
Okay, that makes sense.
Yeah.
Like dependencies always makes it a lot difficult because if it's a JVM and all that.
Yes. If it were easy, we wouldn't have jobs, I think. So,
Yeah.
One day. All right, so then let's talk about the options for container hosting, because we just spent a bunch of time defining what containers were and how to build them. Remember, a Docker file with a capital D, everything else is lowercase, is the file that imperatively declares step-by-step how you build a Docker image. Docker images are then deployed onto orchestrators like ECS and EKS, right? So here the operations manager is like, we need hosting options. Because I just want to tell you is that I love Kubernetes. I think it's a great piece of software, and it is a horrible like learning curve to like really become good at Kubernetes. So, just know that a managed option like this is where everyone's pretty much headed with Kubernetes, because everyone was so excited about rolling their own back in 2017, 2018, and 2019. And then they lost weeks of their lives trying to keep it up. And then they realized that the providers were like, hey, we have a hosted option. And so this is where the container landscape becomes really attractive because, you know, AWS, and just to mention this, all of the others, and frankly, the best is GKE. So if you've used GKE, then you already know. But it's not that the others are far behind, but Google wrote Kubernetes, so they're really good at running it, right? But here, notice that ECS and EKS on the left-hand side, which means like these are the things that are going to manage the containers. And then for both of those, you can actually have them hosted either on a virtual machine or on a virtual machine that you don't manage, right? And by the way, even though I said that, EC2, the EC2 launch type does have managed and unmanaged as options, which means it's more like more managed, but it's not serverless. With Fargate, you actually don't see any servers. You cannot even log into them. And then of course the container registry, which is required actually to deploy images, right? So note that you can use the Elastic Container Service or the Elastic Kubernetes Service to both deploy images, but ECS is proprietary to AWS. So you learn about AWS's proprietary ecosystem, but ECS is simpler to use. It also has less features, but it has better integration. Makes sense, right? Amazon wrote it, so they can make it more integrated. EKS is a CNCF certified distribution of Kubernetes. So this is industry standards compatible, but you get all of the complexity and headaches of Kubernetes with all of its compatibility, flexibility, and extensibility. So Kubernetes is amazing, and Amazon takes a lot of the operational overhead off your plate for you, but you do have a learning curve to you learn Kubernetes, but you get all of the amazing compatibility with the rest of the industry, right? So all of the tooling that will work with a standard Kubernetes distribution will work with EKS, with like maybe like one or two exceptions. But for the most part, almost everything I've run inside EKS that I've run inside of a standard Kubernetes distribution, it'll run on EKS.
Is there a business or technical reason why you might choose EKS over ECS?
You might, because you don't have the operational bandwidth in order to have your team learn Kubernetes.
Yeah. Let's say you had the bandwidth and you had people that really liked it. If you want to make your life easier, why don't you say, hey, Amazon, just go manage and we'll tell you what the configs are?
Yeah, this getting easier and easier. As far as I'm concerned, Fargate on EKS is the best of both worlds because you don't have to manage a bunch of servers and you get all the power of Kubernetes, and you don't have to manage the what they call the control plane, the thing that actually like runs the Kubernetes cluster. So I actually think Fargate on both sets is actually really nice. But if I was going to run Kubernetes in production, which actually I just actually did this, I actually try to use Fargate as much as possible. Right. So I've done 4 major deployments of Kubernetes of like, 1,000 containers or more. And actually I just ran a proof of concept for the NFL of like, it was like 49,000 containers across 4,000 hosts. And we use managed Kubernetes for that. So I would highly recommend that. So I think honestly, if you're in today's world, especially if you want the future flexibility or compatibility with other clouds, you're going to use EKS.
Okay.
Yeah. If you just want to run off and you don't want the headache of having to deal with Kubernetes, I would just use ECS. All of my cron jobs, by the way, typically run on ECS inside of Fargate if they need to run 24/7.
So Michael, I mean, it's not only this one, like any of the sample questions throws me out. So where the question or the options that they provide have like both options like ECS and EKS, like I would not like memorize what is supported, what is not supported feature wise between ECS and EKS, right?
No, the only reason to choose EKS over ECS is that you want industry standard compatibility.
Okay.
Otherwise, the feature sets are standard. Like if you wanted to run a custom Kubernetes tool, you can't use ECS for that, right? So those kind of questions are actually easy. They do show up that way, by the way. But like, hey, you've written a custom Kubernetes tool that you want to use to extend Kubernetes. Where do you run your containers? And of course, it lists ECS and EKS, right? And then right? Because both of them will run EC2 mode. Both of them will run Fargate. But if you want industry standard compatibility, EKS is your only option.
Yeah, I mean, as I said, this is not common, but this is not uncommon that two of the option in the answers are very close, and like like at this point, I even don't dare to book my exam at this point, looking at those numbers.
Oh, yeah. Well, Saif, I wouldn't expect you to. Just to speak to that, none of you should be ready, should feel like you're ready to take the exam. No one, right? One, we haven't even covered all the material. And two, you're going to need to go through about 100 questions and probably the process of deconstructing the questions that you get wrong before you feel even remotely comfortable. None of you should feel like you're ready to take the exam, right? We're only on our third day and you've only really just started practicing. So, the exam, I think the deadline is like a week from Friday. The idea here is that you're going to be obviously finishing this course and then just running through the practice exams. But right now you should feel like you are utterly failing, because that's actually, in a sense, what you're doing. You're not failing, but you're learning. And so you shouldn't know the answers to any of this, and you shouldn't understand the distinctions, and it all should feel very foreign, right? But what will happen is that if you keep going at it, right, what will happen is you'll start getting some right, and then you'll start getting more right, and then you'll get more right. So Saif, I'm glad you aired that, because nobody who can hear my voice right now should feel like, man, I'm ready to take the exam. You should all feel like you're losing right now, but you're not actually. You're actually winning. You're just winning in very small ways. So just my only statement around that is just keep going, because as you get exposed to it more and more, it's going to sink into your brain. It's going to cement, and it's not going to come in a flash. You're going to win a little bit. You're going to start winning a little bit more. And the next thing you know, you're going to be like, you know what? I actually know enough to actually potentially answer these questions. But that's only going to come when you deconstruct how you're getting the questions wrong, right? And of course, obviously, like getting exposed to this material, right?
Yeah, and are all questions like 1 page long in the exam?
Yes.
Oh,
Yeah. This is the pro exam, right? So all of them are that long.
okay.
Yeah.
Wow.
Don't worry. It should feel defeating, but we're going to keep going, because you are going to get it, right? As long as you just keep hammering away at it. Right now it should feel insurmountable, but it's not, right? So just keep working those practice questions. But if it feels like you're, man, I really don't know the answers, just make sure you're being methodical. This is why yesterday I was advocating slowing down and deconstructing your reasoning, so you can understand either what you don't know or what you missed in the question that would have given you the answer, right? So yeah, just stick with it. I know it's uncomfortable. All right. So EC2 launch type we talked about, right? So this is for ECS in particular, right? So this basically, the way this works is that when you launch a cluster, it creates what's called the control plane for you. The control plane are where all the like controllers are, like the API server and the scheduler and all this other stuff that honestly you don't really need to mess with, right? Where the containers run is called the data plane. And this is going to either be on EC2 or it's going to be on Fargate, which is basically hidden servers, right? So the control plane is where you've got worker nodes, which make up EC2, or you've got Fargate nodes, which are actually just really, they're just like pods. They're just like containers, really. So with ECS, you can use standard virtual machines, right? You can turn it into a cluster. You've got services and tasks that combined are used to kind of create the containers that you're running. By the way, when you use EC2, ECS is going to determine where to place what they call tasks, which is also another name for containers, based on task definitions. This is something that's on the exam. ECS, whenever you want to configure a container or declare a role or set security permissions, you have to change the task definition. The task definition is the deployment file inside of ECS, right? And so in ECS, they don't really call them containers, they call them tasks, right? But in that task definition, which is actually a file that you can upload also when you submit a workload, that task definition contains things like how much memory do you need, how much CPU, what image am I going to download? A task definition is a way of defining a container inside of ECS. Now, if you use EC2, that goes on a virtual machine. Which virtual machine? ECS is going to handle that for you unless you specify one. If you use Fargate, what actually happens is that they create a tiny virtual machine just for the size of your container. So if you tell ECS that you need a 2 gig machine with 2 processors, it creates a 2.2 gig machine with 2 processors, and it creates a virtual machine and then sticks your container on that virtual machine. Isn't that a weird thought? I don't know who came up with this idea for serverless, but this is how they do it, is they run what they call micro VMs, also known as Firecracker. It's the official technology. And they run these tiny little virtual machines that are just slightly larger than the container size you've asked for. You only pay for it when it's running. So instead of paying for an entire virtual machine that only has 1 container on it, you pay for a tiny virtual machine that is the exact size of your container, right? And you don't have to manage anything, right? They manage all of that for you. You just tell them what size container you want to run and they start everything up for you. You want 50 of them, they'll run 50 virtual machines and stick your container in those virtual machines, and they will be exactly sized for your container. So with Fargate, you're not responsible for the worker nodes, right? You're not responsible for the instances, the virtual machines that are hosting all of your services and your tasks, okay? Well, Parth, just to be clear, every container runs on a virtual machine. What you're doing is that you're making the virtual machine more efficient, right? And since you're not managing it, right, it's not something that we have to worry about, right? All we're doing is running containers. AWS is handling it. Remember that you still have to run a virtual machine to host multiple containers. And in a sense, you're right. Wouldn't one-to-one be efficient? Because you're like, hey, Michael, didn't we want to get away from running one-to-one applications to one virtual machine? Absolutely. And so it is inefficient, but not for us. It's inefficient for Amazon, right? Which is why they do it, because they're eating the operational costs. That way you can just worry about running containers.
Do you know, Michael, if ECS is typically cheaper, ECS on Fargate is cheaper than either EKS on Fargate or running it on EC2?
It definitely is cheaper than running it on EC2.
And it's always surprised me that Amazon does more work, but it's cheaper than doing it yourself.
Well, because the size of the virtual machines are smaller, right? There's more orchestration and management overhead, but the virtual machines are smaller. So for them, it's actually more efficient.
And then you cannot go out of Amazon. So they're investing a little more with your workload.
Yeah.
Just like Lambda, as soon as you use Lambda, you cannot go out.
Yep.
Well, not as true with containers, right? Because you can pull that container out and run it somewhere else. Right? The container is portable. You could throw it right into GKE, no issue, with almost like no modification. But you're right in a sense of like all the work that you did to orchestrate that deployment of that container, you'd have to write that, you know, if you're using Terraform, you have to obviously write the Terraform for the provider for you know, G Cloud, right? So.
Yeah, and my question would be like, if I'm using ECS, can I use CloudFormation?
Oh yeah. Yeah, absolutely.
Yeah. Okay.
Yeah, this whole setup to deploy to ECS Fargate, we have currently a method using a CDK to do that.
Oh, yeah. Okay, so you are using CloudFormation. Just to be clear, every single service we're talking about is configurable through CloudFormation. The only things that typically aren't configurable through CloudFormation are things that either require a root owner access, like weird billing stuff, or if it's a brand new service, right? If it's a brand new service, it takes them like a month or so to catch up. But most of the time, they're actually right on top of new service releases. So all of this can be orchestrated typically in CloudFormation. Okay, let's see. With the EC2 launch type, by the way, you can use the same task definition with ECS in order to specify like the container and its size and any dependencies in the container or whatnot, which image you're going to use, etc. Right? But then what happens is that you use the ECS API to launch the containers, And what they'll do is they'll deploy it on the worker nodes that you've specified, right? And so remember that since all of this with both EKS and ECS is running on virtual machines, it does mean that all of your security groups and your VPCs and your subnets, all of your standard networking stuff is actually in play, right? So it doesn't negate you from having to manage that as well. So just something to be aware of. And of course, all your security issues apply here as well, because you're running EC2, right? So the only difference is that typically they use a Linux OS. Oh God, it's not Amazon Linux. I think it's called Bottle Rocket. It's Amazon's OS, I think, built specifically for this, and it's really locked down. So I think you can download a copy of Bottle Rocket offline and run CIS scans and benchmarks and whatever against it, but it's a very slimmed down Linux version. With Fargate, by the way, which is the serverless version, just remember that you cannot access the infrastructure in any way. And it is cluster level isolation for your containers. So containers that are all part of the Fargate profile that you're running, who are all in that particular cluster, you can't actually enable them to talk to each other really easily. So, but that's actually typical with most clusters, is that unless you enable some kind of security cordon, like with Tigera or Calico or something like that, your containers actually could talk to each other if they're exposing ports to each other. Okay, so that's just ECS and EKS as options. Remember, EKS, if you want industry standard compatibility, the other thing to remember is that ECS uses task definitions to define CPU, memory, image type. Just remember that. Kubernetes, by the way, EKS uses YAML files. It uses what they call pod specification or deployment specification files. They use deployment YAML files is basically what they use. All right, so that was all ECS. There's more ECS. Oh yeah, I guess we are hyper focusing on ECS here. So EC2 and Fargate we've already talked about. ECR is in play because remember, both ECS and EKS, once those worker nodes or Fargate is up, it's got to go talk to a container registry to download the container image. Remember that, right? If you've got 50 worker nodes, they have to talk to a repository to download those images. So ECS is the container management system, that is proprietary to AWS. And so it does, cluster management, orchestration, and obviously it has deeper integration with AWS. Parth, you can use an external repo for ECS or EKS. So you could actually use hub.docker.com if you wanted to. You might need to create a pass-through, right? Like a proxy, but you can get that working. Cluster management as a hosted service, right? So this basically allows you to set up your worker nodes and they'll manage it for you, right? You can log into these worker nodes. The container agent that runs on these systems is actually available on GitHub. So you can actually literally download the actual agent that AWS is running in their infrastructure, right? But you can submit pull requests, but they will not allow you to run your own modified version of the agent on your AWS infrastructure. You have to use theirs, right? So notice that most containerization profiles are stateless, but if you're running a database, you probably want stateful, right? Because you don't want to lose your data. You don't want to restore the database every time you restart the database application, do you? No. So just know that you can actually use not only volume storage, like the EBS volumes, or even the EFS file system, which is the network file system. You can use both of those to mount inside of your containers, inside ECS and EKS. So just know that you can actually use the fast storage options, but also you can just write your data out if you want to with your application to external databases like RDS or whatever. It is recommended that when you first start using these services, do not run a database. Save that for later. Get used to running stateless applications first, then start running databases, because then when you add state into a system, things start getting a little more complicated. So remember, by default, container storage is ephemeral unless you add a persistence layer to it. So EBS, EFS, or write your data out to an external third party. So something that you probably want to pay attention to, like this is a great slide, if you will. This is slide 41, right, in this module. What module is this? This is module 6. So something to really consider is that this is probably a great thing for you to memorize, right? So task definitions basically contain all the configuration information for your particular container / task. Container virtual machines like EC2 instances are actually going to run your tasks, right? If you want to like stop or restart the agent because let's say it's not updating the image or it's hung for some reason, knowing that you can stop and restart the image is probably something to keep in mind. A service is like a deployment in the sense of like a service says, hey, I want to run 5 copies or 50 copies of a task. So think of a service as a meta definition of what a task would do. So think of a service as like, I am offering a service. A service is comprised of tasks. In a service, you would have meta information. How many tasks do you want me to run? How many do you want me to keep up? That kind of thing.
And which tasks to run, because you can do different tasks.
That's right. You could have multiple tasks in there, right? Because you might have 3 or 4 applications that make up your product or service in this case, right? Like database, web, app, as an example, using the traditional 3-tier. So this is probably something to make sure that you really have memorized, right?
And then the cluster, from what I've seen, the way I thought about it, it seems that it makes sense more to me. It's like a folder. And literally just a logical, that weird, just the grouping doesn't really do anything other than it's like a visual way, at least in the GUI, to see things.
Yeah.
I don't recall that there's any actual configuration there that's of any use.
Well, yeah, I mean, if you didn't, oh, don't get me wrong, you can configure the cluster like, is it a EC2 launch type or is it Fargate?
Right.
What kind of worker nodes it has in it? How many worker nodes does it maintain? How does it scale? So there is some cluster specific settings,
Okay.
right? Because remember, services and tasks are application specific. So they're specific to containers, right? But there are
Okay.
a lot of cluster settings related to how the cluster is going to run, how it's going to auto expand and contract. Is it in an auto scaling group? That kind of thing. Is it using spot instances on demand? So
Gotcha.
the cluster does have a lot of attributes and configuration to it.
So I'll need to look into that more then. Okay.
Yeah. So, and clusters are region specific, but Brad, you're absolutely correct to think of them as groupings. A cluster is nothing more than a collection of resources that serve a single purpose. In this case, container orchestration.
Yeah.
Okay. Note, by the way, that you can actually, since ECS is kind of like shared state, you can either run a task, like you can have it trigger like on demand, like I want you to kick this container up on a trigger, or you can just have it set up with a service with a bunch of tasks and have it like has a long running kind of application. So do note that a lot of people will actually use ECS as a target for like application load balance or something like that, and it just like will trigger the task. It isn't necessarily even running. So they're getting better at cold starts, but typically most people are going to be running 24/7 applications in ECS. So unless the question specifies it, assume that they're running a 24/7 application, right? In the scenario, right? So, because you can't actually do event-based like you can with Lambda, or trigger-based like you can with Lambda, trigger-based execution of tasks. You can't do this, by the way, with Kubernetes. Not yet. So task definitions, by the way, say which image to use, what are the port mappings, all the resources, what are the roles. Note, by the way, that roles are set inside of a task definition. Make sure that you know that, because they will ask questions on that. They'll try to trick you and say, hey, we're going to set up a username and password inside of a task definition. No, it's a role, right? Because you're not going to stick a username and password inside of a container, because that's a no-no, right? And then it's going to say, well, we're going to stick the role definition inside the container definition. It's like, no, we're going to stick the role definition inside the cluster. No, you're going to stick the role definition inside the task definition. So you're going to define the role inside the task definition. So I've seen at least one question on that, if not more, right? If you want to attach volumes, by the way, that would happen here. If you want to expose ports, that happens here as well. The task definition is really where everything happens, right? So you can, by the way, define multiple containers and data volumes in a task definition. But, typically, if we want multiple tasks, we do that in a service because that's the meta. So one key difference is that remember that you can set resource limits with your containers with an EC2 launch type, but if you're using Fargate, you have to. So whereas it's kind of optional if you're using EC2 because you have a whole virtual machine available to you that's bigger than your container. If you're using the Fargate launch type, you have to specify the CPU and memory, right? So just know that the definition is a little more complicated with EC2 launch types versus Fargate. So with ECS, you create a Docker image using a Docker file that's published to ECR. Then you create your task definition and optionally your service description and definition as well. And then what will happen is you give that to the system. It'll place the task, download the container image, and then run the container image on the host in question. And that's all going to happen on the data plane or the worker nodes of a ECS cluster. If it's Fargate, it's a little bit different. When you do a task definition with Fargate, it actually has to match a Fargate profile that you have set up inside the system. If it matches a Fargate profile, Amazon will kick up a virtual machine and then deploy your image to that tiny little virtual machine. Relatively, right? Depends on the size of the virtual machine. I think that Fargate can grow up to 30 gigs in resident memory now. It used to be 10. I think it went up to 30. It's really big, actually. That's a big application. So obviously there are use cases that are far beyond that, but they've gotten pretty large. Notice here that we got a bunch of JSON files that are kind of like being ingested to define the task definition and service definition, and then that gets ingested and it gets placed in the cluster. You can also, by the way, do this inside the console, right? Task placement, how does that work? So task placement is remarkably rational. This works the same way, by the way, in Kubernetes. Do you have resources available to run my application? Yes. Then you go on the list. Then there's a list that gets created. And then what happens is that it then looks and says, hey, have you specified any task placement strategies? By the way, there's placement strategies are actually listed inside of the AWS documentation. You want to do a one over on the task placement strategies. I'll put a link in here in a second. You all want to eyeball that link because I don't think they talk about the task placement strategies, and there are questions on the task placement strategies inside the. And so if you're taking the practice exams, you are going to see questions on the task placement strategies. That is all over the exam. Some of them as it says here, spread, bin pack, or random. Spread is like spread across. Random means it just randomizes. Bin pack means it places everything on the same host. So there's different placement strategies. But once it identifies who can run your application, what it does is it says who would be our favorite. In other words, if I get a system that has 100% free memory and a system that has 50% free memory, it's going to choose the system that has 100% free memory, right? Because that, even though they both can, you're like, hey, I want the person that has less resource constraints, right? I want the machine that has less resource constraints. So just know that the process for choosing where it's going to run your stuff is at first very binary, comes up with a list, and then decides who's better at running your system, right? So a capacity provider, by the way, basically is associated with it determines what infrastructure that a task is going to run on, right? So it's the one that does the assessment and figures out like, hey, who like has availability or who meets your categories. Just know, for example, that there are like, for example, Fargate has a Fargate capacity provider, and it has a Spot capacity provider. So Fargate, by the way, can run on Spot instances as well. if you have tasks that don't need to be, that can withstand interruption, right? So, yeah. And like this can include, for example, auto scaling groups. If you have like an EC2 capacity provider, so you can have like multiple locations where you could deploy your applications. This doesn't show up really heavily on the exam. I don't think I've ever seen or heard of a single question about this on the exam, just because it's actually pretty simple. So the ECX cluster determines who's going to run where based on what kind of capacity providers you have defined, right? Fargate, by the way, the capacity providers are predefined and you can't really change them. With EC2, you can set up different auto scaling groups or do fleets with like on demand or spot instances, and you can create your own capacity providers with the EC2 launch type. Let's see, a capacity provider strategy gives you control how you use the capacity providers, right? So, you know, here, by the way, you can designate how many tasks at a minimum you can run in a capacity provider, whether the capacity provider should expand. You can weight your providers and say, look, I want more providers on these systems than I want on these systems. Most people don't get that complex, right? So they don't really create a custom provider strategy. Most people run resources on a per cluster basis, not on a per capacity provider basis, which is why there aren't a lot of questions, if any, around these capacity providers. Just know that they exist, that you actually can control what the like worker node capacity looks like inside of your clusters, and you can create different types of nodes for different types of workloads. Let me give you an example. Let's say you create a capacity provider and it just has general M5 instances on it because they're general container workloads. Let's say that you then have another capacity provider that is running accelerated computing because they're running GPUs for your machine learning workloads. You could specify that certain tasks should run on this capacity provider that has GPUs attached to it because they're optimized for machine learning. You could have another set that is optimized capacity provider that just says, no, all the rest of the workloads by default should go over here. And so if the task definition includes a certain tag that says this is a machine learning app, then it could go into that capacity provider instead of going into the general population. You could also do that with Windows versus Linux. In a cluster, you can have Windows nodes and you can have Linux nodes. You could put those in different capacity providers and then have a strategy that says, look, if the tagged on this task definition says Windows, put it in the Windows capacity provider. Does that make sense? A lot of people don't do that. What they'll do is they'll run separate clusters. But people who are super cost conscious won't do that because, just so you know, it's 10 cents an hour to just even have a cluster existing. Right? That annoys some people. Because then if I run 3, 4, 5, 6, 7 clusters, I'm paying $2.40 a day, which, you know, most people like, is that really that big of a deal? Well, you know, if you're running 100 of them, probably starts to add up. It all adds up eventually, right?
But a capacity provider, I think one way to say that is it helps determine what type of compute resource you're deciding that you need the task service to be running on.
Right. And then how that resource is managed. Is it, does it auto scale? Is it static? Is it spot? Is it on demand?
Okay.
That kind of thing.
That hint about using the tags to determine, help farm that out, that's really neat.
Yeah. Tagging is almost required in Kubernetes. It's not so required in ECS. Now, I got to tell you, I think this example is pretty bad. I don't know why you would have infrastructures that you would favor one over the other. Usually it's very binary. This is a Windows box. This is a Linux box. These are machine learning boxes. These are database boxes. Like I don't agree with like this kind of weighting strategy. I'm sure there's ways you could do this, but then why would you run clusters where you favor one over the other? Usually it's exclusion. It's not favoritism. So, all right. Here, by the way, we've got 2 auto scaling groups and 2 different AZs. By the way, auto scaling groups can scale across availability zones. So I'm not sure why this is up, but like if you wanted to be very explicit and isolate, you know, hey, make sure you're here in this availability zone versus this availability zone, you could use the capacity provider. The weights would be equal, right? So you balanced it. So this is one way that you could approach it. I gotta tell you, I'd probably just run one availability zone across both AZs and do something different with that. But if you want control, this would allow you to do that. Now, ECS cluster comes in certain states. It's either active, it's either provisioning, which is usually the first state it's in. It's like it's standing itself up. Then it gets into active. If you then like shut it down, it's gonna delete it, right? And then of course, if it once it's been deprovisioned, it goes into an inactive state, which means that it's deleted. It's actually going to show up for a period of time, and then it's going to go away, right? And then failed means that something happened. Something went wrong. That's what failed means, right? So remember, starts in provisioning, goes to active, then it deprovisions, then it's inactive. If it fails, it just goes to a failed state. I have never seen a question on this. And when I say that, I also mean I've never heard a question on this. So, but just in case. Here's an event stream, by the way, where you're using ECS to trigger event bridge into Lambda, then to SNS, and then, you know, the ES, by the way, stands for Elasticsearch or OpenSearch, which is what they're using now. But this is an event stream where basically ECS could trigger other responses, right? But honestly, you could also do this in reverse. You could have Lambda trigger a response into ECS. So it's basically just showing you that it has really good tight integration with other ECS services. With Kubernetes, you'd have to write the integration. Like, you know, it'd be a command line call or something along those lines.
When you say ECS has this ability, is it the ECS service or your app? How do you split that difference?
It's an ECS service.
Okay.
Yeah. So what happens here is that ECS actually has an event stream, right? That can drive like real-time updates about the state of a task, auto scaling, expansion, that kind of thing. Those events can be used to trigger a Lambda response using Event Bridge.
Gotcha. The meta state about
Of the
what's
cluster.
happening. Yeah.
Yeah.
Gotcha.
Yeah. EKS doesn't have that level of integration yet.
Yeah.
Other cluster notes is that clusters are specific to a region. They don't span regions. A cluster may contain a mix of tasks. So you can actually have the same cluster have both Fargate and EC2 launch types and multiple capacity providers. So clusters can contain both auto-scaling groups and Fargate capacity providers. So you can set that up however you wish. You can create custom IAM policies to restrict access to specific clusters. And you can assign roles to task definitions. Like, sorry, you can assign roles to specific containers/tasks that get different permissions. So it's not just being assigned just to the underlying EC2 instances. Notice that there are, Fargate is different in a lot of ways, right? So when you launch Fargate, by the way, you have to use the AWS VPC type. You can't really use like the none, bridge, or host like types that like are available to both Docker and Kubernetes. It doesn't matter. You're not going to do that anyway, just to say this. Unless you have a really like edge case, you're going to run your containers inside of your VPC because they're going to be on hosts, right? Those hosts are going to live somewhere. They're going to live inside your VPC. So they make this distinction, and it's come up a couple of times. The only time this becomes painful is that if you're using EKS and you want to use a custom network provider that's not AWS VPC, that's when it becomes problematic. But when it comes to ECS, there's nothing, this isn't even really a conflict, right? You're not going to use bridge and you're not going to use host, and you're certainly not going to use none, right? So yeah, as a general rule of thumb. Fargate does support ALBs and NLBs, so it does support, I don't think it supports gateway load balancers yet because it doesn't work that low level from my understanding. But I'm sure that will happen soon. Notice here that your Fargate task is actually going to run, right, with a network card inside your system. So it's actually going to use that for, you know, obviously ingress and egress, right? Remember, Amazon loves to take their services and run them inside your VPC using ENIs, the network interface cards. So they'll do that with Lambda too, by the way, if you want to do that. You actually run your Lambda instance inside your subnet, inside your VPC. So just know that Amazon loves ENIs. So anything that they run on a serverless infrastructure, you can typically attach to your VPC using an ENI. Okay, last but not least, before we roll into a lab, is Amazon EKS, right? So we've already talked about a bunch of this already. Kubernetes is an open source platform published by the CNCF. The only thing that really changes is the terminology. So instead of tasks, Kubernetes uses pods. Now we use pods because what's the mascot for Docker? That's right, it's a whale, right? So pods, groups of whales are called pods, right? Now services are still services, right? The control plane is still a control plane. Worker nodes are still worker nodes. Remember, the control plane is the thing that manages the cluster that you really can't touch. That's why you're running it in Amazon, because they're handling that for you. If you are running Kubernetes by yourself, by the way, you'd have a whole set of boxes whose job it was to manage the cluster. But in Amazon, you don't have to worry about that. They hide that from you. They take care of that themselves. So otherwise, all your tasks and or / pods run inside the worker nodes, and it works just like ECS. You also have Fargate and EC2 mode, so all of your understanding of that is applicable here as well. You know, and the only difference is that typically your Kubernetes cluster is managed through what's called kubectl. KUBECTL, which I'm actually going to type in the chat just so you know it. Sometimes affectionately referred to as kubectl, is a command line tool that you use to cuddle with your K8s servers, your Kubernetes servers. By the way, sometimes you'll hear them refer to Kubernetes as K8s. Why? Because someone regretted giving Kubernetes a long name. That's why. The number 8 is all the letters between Kubernetes as far as the count. That's why they use K8. So K8s, sometimes referred to as K8s. Kubernetes EKS is integrated with ELB, so load balancers. It can use IAM for authentication. You have to set that up. It uses VPCs. You can do ENIs, so you can do private link, right? The whole network card thing. And then you can use CloudTrail, CloudWatch, all the traditional services. The EKS solution looks the same in terms of it has workers. Those workers can auto scale, right? So you can set that up. Here's the difference. Kubernetes is cloud aware, meaning when you stick it on a cloud, Kubernetes knows it's on a cloud and it will manage the cloud for you. So you can tell Kubernetes to auto expand your EC2 instances. You can tell Kubernetes to kick up a load balancer for you. And Kubernetes will do that, assuming it has permissions to do so, of course, right? You have to give it permissions to talk to the account on your behalf. You can also, just like ECS, you can mix in spot instances. And just like ECS, there are managed node groups where Amazon does all the deployment and management for you, but you can still log into them. And there's unmanaged node groups where you have to kick them off and bring them into the cluster, right? I say you have to kick them off. It's a push button deployment, but yeah. Notice it has a 99.9 SLA. So Amazon doesn't often publish SLAs for their stuff, so it's good. Notice, by the way, 100% open source. This is 100% upstream compatible. This is a certified distribution. Now, here's the distribution list, by the way. So notice that, you know, customers want a consistent EKS experience. So no matter how you deploy Kubernetes, you can actually download their EKS distro if you want to. You can download their version of Kubernetes and run it on your local infrastructure, right? You can also run it on your own hardware, sorry, on their hardware in your data center, which is what Outpost is. And then, of course, once you get into cloud, you're not running it on premise. You have your options of EC2 and Fargate launch types, which is exactly like ECS. I can't remember. They also have another version that's not listed here called EKS Anywhere or ECS Anywhere. That allows you to download and run the distribution on your hardware, and it can be managed by AWS. It's just like Anthos, by the way, for Google, for those of you familiar with Anthos, right? Anthos basically allows you to run virtual machines and other people's infrastructure, and Google will manage it for you. If you guys haven't seen that, it's really cool. It came out a couple years ago. So Google has the same thing, but obviously for virtual machines. I don't think Google has that for GKE yet, but Amazon does. So just know you have tons of options for how and where you run your EKS distribution and how it gets managed. Mainly though, I would focus on the hosted versions up in cloud, because you're gonna eat all the operational overhead otherwise. If you want to do migrating self-managed Kubernetes to EC2, basically, this allows you to route deploy all your workloads over onto the managed Kubernetes, and you can literally just cut over your DNS name, right? And you can do it with weighting. So notice here, they're doing 90% on the old cluster and 10% on the new. So kind of like a canary deployment or a linear deployment over time. So this basically allows you to take your entire cluster, get read, and then deploy it up into Kubernetes, right? So you will have to, by the way, do a lot of manual trickery to get this to really fully function. It's not fully automated. So my recommendation, just stand up a whole copy of your workloads up in EKS and just cut them over maybe one at a time instead. So the tool that they use for this kind of migration, by the way, which doesn't necessarily show up on the exam, but it's just useful to know, it's called Valero. Valero is a backup, Kubernetes backup and restore tool. So Amazon just wants you to know that you could migrate all your stuff over to EKS. All right, quick knowledge check. Any questions about EKS or ECS actually before we roll into the knowledge checks? No? Okay. So first and foremost, what is a set of instructions written in JSON to tell Amazon ECS how to run a Docker container? That's where I crossed my fingers. Remember what I said. Remember what I said, right? Which one is it? Yeah. This one is asked. You're pretty much guaranteed to see some reference to this on the exam. Number 2, so task definition, just to make sure in case you missed that, because I didn't get necessarily a flood of answers.
But technically not JSON, depending on where if you're doing in CDK, it's not JSON. So
Right,
yeah,
but it's converted to JSON when it's submitted.
at the very end. Okay, fair enough.
Yeah. But you're right.
Hung up on that word. I'm like, what?
Yeah. I probably wouldn't have put JSON in there, but yes, you're right. But it gets converted to JSON at the end. You can run Fargate deploy containers and Amazon EC2 deploy containers on the same cluster. Is that true or false? Can you mix launch types, right? Can you mix auto scaling and Fargate? Yeah, I very explicitly said actually that you could. You can actually run Fargate and EC2 workloads on the same cluster. So, so they'll allow you to mix, right? Because they know that some people get annoyed at having to run multiple clusters at 10 cents an hour. Yeah. Okay. You can use Amazon ECS API calls to launch Fargate containers. Now with Kubernetes, you have to use YAML files. So you have to use kubectl and manage it. But oddly enough, with ECS, just like DynamoDB, right, is integrated really tightly in with AWS, the answer to this is yes, right? You can actually just use the API calls. With Kubernetes, you have to use the Kubernetes API calls, not the Amazon, not the AWS API calls. I know it's a weird concept, but think of it like if you stood up a database on top of Amazon, you have to talk to the database and use the database's protocols to manage the database. You can't use Amazon because all Amazon did is stand up the database system. With Kubernetes, you're standing up the Kubernetes system, which means you have to talk to the system to manage it. Same thing with an operating system. When you stand up Windows, you don't manage the Windows operating system through the AWS API. You have to log into the operating system to manage the operating system. So remember, when you stand up systems on a cloud provider, you typically have to manage those systems independently. That's mainly infrastructure as a service, correct? Sometimes platform as a service in this particular case. But ECS is more of a SaaS. So that's all API driven. What are the volume storage options for ECS containers? Remember, this is all going to be AWS specific, right? So yeah, good. Yeah, so ECS Instant Store, because remember, that's attached to EC2, right? That's the instant storage that comes with an EC2 box. Typically, we don't recommend you use that because it's temporary. EBS, which is persistent storage, right? So that's the hard drive service for EC2. And then EFS is the NFS file storage for EC2. Container storage is temporary, right? So that's typically not a volume storage option because you get that by default. It's not a volume. It's automatically created for you and you can't manage it. So container storage is the one that is not part of the volume storage options. Good. Okay. Which services perform container orchestration operations? Yes, I did add the word container. Good. Yeah, A and D. Perfect. Haha. We're on to a lab. All right, everyone do me a favor, by the way. Please just go ahead and log into webage.quicklabs.com. And if you haven't done it already, go ahead and click on Start Lab because sometimes these labs will de-warn themselves if they've been sitting there for too long. And we took, we want to make sure that like you have time to run through this. Okay, so in this particular instance, we're gonna basically, it's gonna stand up Kubernetes clusters for us. And you're basically gonna connect to the Bastion host. You're gonna basically create your own Docker image. So you're actually gonna explore the Docker file. You're gonna build your own container. So it's gonna build your own container image, which is gonna be fun. Then you're gonna tag and push that image to a repository, which I am so glad they did this because this has been added recently. They didn't have this in here before. And this is going to allow you to see what it's like to build an image, push the image to a repository, and then you're going to look at your like control plane, not your control plane, your data plane for the cluster and for the managed node group that you deployed to host your containers. And then you're going to explore the Fargate profile, and then you're going to set up and deploy some load balancers. So this lab is actually going to be pretty fun. So my recommendation, go ahead and hit start. It's actually 10:38 right now. Please know that if you need to take a break, please, you can take it now, you can take it later, but we're basically going to reconvene at 11:30, right? So, squeeze it in there as you see fit. But this lab, it says it takes 60 minutes. It actually usually takes far less. But that's what we're going to do. So go ahead and get cracking. If you have any questions for me, let me know. Otherwise, this is what we're going to be doing for the next 52 minutes. All right. So that you understand, at least at a general level, what the different deployment types are. So not that one, this one. All right. By the way, the videos are uploaded up, so I will post the video link playlist out. That playlist, by the way, will be on Basecamp, and so it'll have all the videos. So as they process, they'll just be uploaded up to that playlist. So day 1 and day 2 are already out there. So I'll make sure I post that before we leave today. Okay, so let's talk about CI/CD. So by the way, how many of you are basically working in an environment where your integration and your deployments and or deliveries are completely like automated and continuous and based on triggers? Yeah. I think at this point, this has become a pretty common methodology. Usually I see clients who just haven't really like had time to change it. That seems to be the only time I see people not doing fully continuous. So, I think this has become pretty common now. Oh, that's a good question. So I was at the Velocity conference back in 2009 when Hammond and Allspark announced that they were doing 10 deploys a day, which blew everybody's mind. That's kind of an afterthought now. That's like 12 years ago. How many of you are deploying basically on an hourly, if not daily basis? Like you're doing deploys into production on an hourly or daily basis? No? Weekly? No? How many of most of this group not touching production code, not having to kick off deploys? Because it could be infrastructure as well, right? Doesn't necessarily have to be feature development. No? Okay. Well, then this will be good for you to know, right? Automated end-to-end CI/CD pipeline. Well, this question is interesting, right? But basically the point being is that most of us are driving for a CI/CD pipeline, even for infrastructure engineering. So you're seeing this even more and more, where instead of like running Terraform manually, you're getting a build server to do it, and you're working out of a repo. So you're committing your TF changes, your Terraform file changes to a repo. That then triggers everything that you would normally do manually, right? So why? Because after you do it manually 100 times, it kind of gets old. So why not just let the machine do it unless you're just doing something custom, right? Other thing to think about this is that, this is kind of a marketing slide, is that they want you to think about the fact that, you could lose revenue, customers, weaken your reputation, and demoralize teams if, right, you have a failed software rollout, which is, I've experienced all of those actually. So CI/CD, basically the push for automation just in general, the reason for this push is to avoid all these consequences. All right, so let's dive into CI/CD. And then what we're going to do is we're going to talk about, in particular, just the general concepts around CI/CD, the various code services that you can use, which you're going to get a lot of questions on these, the deployment models, which you're going to get a lot of questions on these, and then you're going to get like 1 or 2 questions on stack sets, which is the last thing. So the idea here is that, this team relies on a CI/CD pipeline in the data center. They want to know basically how it can run in AWS. That's what they're looking for. Additionally, we've got concerns from app developers, architects, and auditors about how do we, simplify and replicate the infrastructure to other accounts? How do we increase security and clean up app holes? How do we basically like test better, and how do we install better? That's basically what these questions are asking. In general, CI/CD's focus is basically, how do we do this? How do we code? How do we build? How do we test? How do we deploy? And how do we get to production, right? I make that distinction between deploying to non-prod and deploying to production, because that's the distinction between continuous delivery and continuous deployment. In case no one's ever said this to you, continuous delivery is all the way up to right before production. Continuous deployment is where you're deploying into production, and continuous integration mainly just happens in a repository. So continuous integration is you merging feature code changes into a deployable branch and testing those changes. If it fails to test, by the way, it doesn't get merged into a deployable branch, because one of the hallmarks of CI/CD is that you always have a deployable branch. You always have a branch that is actually able to be built into a binary or deployable artifact that can be deployed out into production. So that way, right, you're doing small batch changes and you're doing all the testing necessary to make sure that's true. So this is what continuous integration is really for, is really the code portion of it. Continuous delivery and continuous deployment govern basically everything from artifacts to all the testing that happens and the deployment after that. So without a pipeline, this is manual. With a pipeline, right, CI really governs kind of like the sourcing and a little bit of the building. I would argue that pretty much it all happens in the repository. I wouldn't argue that the actual building of the artifact is actually continuous integration, because then I feel like delivery and deployment take over at that point in time. So continuous integration is really about what happens in the code base to make sure all that's working. Continuous deployment and continuous delivery are focused on how do we take that artifact, run it through all of its other tests, smoke tests, environmental tests, all the other pieces, performance tests, And then if you're doing deployment, you're going to go all the way out in production. If you're going to go to delivery, you're going to stop at the last mile right before you get to production. Some people might say, well, why would you do that? Honestly, the most common reason people do delivery instead of deployment is they don't trust their testing facilities. But here's the funny thing, just to say this, if I ask them what they do extra to test, if they don't, they usually just say, well, it's just a manual approval. I was like, you don't do any extra tests. You literally just like go talk to somebody and ask them if it's okay to deploy. And they're like, yes. I'm like, well, you might as well just deploy into production at that point in time because you actually haven't added any additional tests. And like, yeah, but we feel better about it. You can't dismiss that. I want to, but you can't dismiss it, right? So with a CI/CD pipeline, what happens is that all of this like sourcing, everything that happens in the repository, everything that happens around building artifacts, everything that happens around putting the artifact into non-production, right? Testing it and then pushing it all the way to production. All of that is automated, including the confirmation that everything is okay, right? Because if something goes awry, then it just stops the process and lets somebody know that it needs attention. So mistakes are caught earlier in the development process. The great thing about this is that your deployment frequency and your success of deployment changes goes way up. These are leading indicators, by the way, of like high performing organizations, right? Is that what's the percentage of deployments that you do per day and what's the percentage of successful changes that you make, right? What's your velocity? How long does it take for you to get from a repo out into production, right? What's the mean time to release, right? So you can really switch this greatly. Now, that's a general statement around CI/CD, just the concept. And, they're not going to ask you a whole lot of questions about like, can you tell me explicitly what delivery is versus deployment, right? What they will ask you a lot of questions for on the exam, right, is, and this is about improving like the weight, right, the developer experience, is they're going to ask you a lot of questions about this whole swath of code services, including X-Ray, right, and Cloud9, right? And you just really need to know what Cloud9 is. So, yeah, there's a lot here, right? So here's a sample flow where basically we're going from code commit, and then Code Guru, by the way, is a profiler that will use machine learning to like look for holes and errors inside your code, syntactical errors and other common issues. Then it will build, which is what, it's like the actual building process. Like if you were going to build a Docker file, like in a Docker image. And then what happens is you can output the artifact of that build process into code artifacts. And then it can continue to call code deploy. And then once it's actually out in production, you can use X-Ray, which is actually an awesome end-to-end tracing tool. It's actually pretty cool. And then you've got CloudWatch, which obviously monitors every single service inside of AWS once it's launched. Notice that all of this was orchestrated by Code Pipeline, which is sitting at the bottom. And notice that Cloud9 sitting over there on the left-hand side. Cloud9 is nothing more than a cloud-based IDE. Right? And Amazon bought them, so they existed before AWS, just so you know. I don't think it's based on Eclipse, so it's not like the new Eclipse web-based interface. Cloud9 was something a little bit more proprietary.
What is CodeStar, if I missed it?
Oh, don't worry, I was getting there, Saif. You teed me up. So CodeStar is a way for you to tee up the orchestration of all of this. So for example, you know how Elastic Beanstalk is like a best practice wizard for like EC2? That's basically what it is, right? You answer a bunch of questions and it basically just applies best practices and sets up a really cool EC2 based infrastructure for you. Well, CodeStar does the same thing. CodeStar allows you to set up an entirely orchestrated, like kind of like developer pipeline, but it also enables collaboration as well. So think of CodeStar as a way of like setting up a development environment with all of these services except for X-Ray, and you can just have it all set up for you. So.
Do you know anything about the billing of any of these services?
Like Code Commit charges per user, and like if you're on the free tier, you get 5. Code Build charges you per like the amount of storage that you're like, not the storage. Sorry, that's Code Artifact. Code Build charges you for the execution time. Like you have to use EC2 instances or Docker to like do the actual building, so it's going to spin up infrastructure. How long did that run for? That's how Code Build charges you. Code Guru charges you for lines of code scanned. Code Deploy charges you for time and God, something else. Can't remember that one. So time. X-Ray charges you for time run. CloudWatch obviously charges you across multiple dimensions. Code Pipeline doesn't really charge you. Cloud9 charges you based on EC2 instances. So Cloud9 actually runs on an EC2 instance. So yeah. CodeStar doesn't charge you because it just is an orchestrator. But it starts all these services, so it charges you based on that. I have to say pricing for the code services is one of the hardest things to anticipate once you get past code commit, because like how long you don't always know how long a build's going to take, right? Especially when you introduce changes and how often it's going to be run for, because you don't know when people are going to be done with their features. So, but you know, these are minuscule charges compared to say compute and like database charges. So
And then is lines scanned? Is it the number of lines in the repository, or is it every time it does a scan?
it's the number of ones that it actively scans that you ask it to take a look at. Yeah, if I remember correctly. Yeah, so Code Guru is gonna like, oh, this is all you want me to scan? Okay. And the frequency, right? So obviously, if you ask it to do 100 lines 50 times a day, you're gonna pay more if you versus 5. So I feel like something is missing from here, but I don't think there are other code services. It's like they just announced something. Anyway, these are all the code services, and don't worry, I gave you this overview. We are actually going to talk about some of them. So this is another example, by the way, where this is basically using, and this is where pipeline, right, comes in, is it's again orchestrating code commit, code build, and code deploy. Now notice they're writing code build out to an S3 bucket. You could use code artifact for that as well. So I'm not sure why they're making those distinctions, but they're not using code artifact in this case. You can, by the way, throw Jenkins in the mix here. You can throw in other third-party tools, so you can externalize stuff. You could get Jenkins to orchestrate all this if you wanted to. So just know it does. You can put integrations in here. Here's another example of the same code pipeline. It looks like the exact same thing. Hold on. I am not sure. I think they were just showing the benefits of the sample pipeline, but it looks like it's the exact same thing. Oh, they're just listing benefits on the left-hand side. Okay, moving on. All right, so code pipeline is here doing the orchestration. Code commit is actually doing all the sourcing. So this is going to host the source code. Code build is the build service. So think of this as kind of like what Jenkins is typically set up for. Jenkins kind of fits in that weird space between code pipeline and code build, because obviously Jenkins can run pipelines. It can also obviously build things, but like Maven and Gradle or NPM, like stuff like, well, NPM does dependencies, but anything that builds a piece of software, that's really what code build is replacing. Now we say that code build often just calls those tools. So it's an interesting kind of place for just to like invoke those, right? Code build, though, what the cool thing about code build is that it provides pre-packaged environments for those tools to run. So it'll provide like environments that are already set up for Maven and for Gradle and for other services, right? It can also run your own custom build tools. So you can specify your own custom Docker image or your custom EC2 AMIs. And code build, by the way, will scale based on peak build requests. So if 50 people are running things concurrently, it'll spin up 50 different environments and then shut them down when it's done, right? And it is on demand, right? So, and then code deploy is cool. Code deploy, if it's not an AWS integrated service, if it's like EC2, or if it's on premise, which it can do, it will deploy software. So you can get it to deploy software to any operating system that will run the agent, the code deploy agent on there. But it will integrate seamlessly with Lambda, the Elastic Container Service. I don't think it integrates with EKS, but that's not really, you wouldn't really use it for that anyway. It's a whole different thing. But you can actually still push actually to EKS, but I don't think the agent runs natively there. Integrates with auto scaling, minimize downtime. There are different ways to deploy with code deploy. which is something they like to ask questions about on the exam. So just, just so you know. Now, code deploy in particular has what's called an app spec file, and it has all these different stages. You're going to have to memorize at least the existence of these stages, right? Note that it says stop the application right before you do an install, after you do an install, right before you start the application, which is the new application that you just installed, correct? And then what do you do once everything's like, how do you validate the service, right? So these are just stages that where you can insert scripts in your process. So if you're like, I want to do this right before the application is stopped, or I want to do this before install, I want to do this after install, you can insert your tasks, your commands in there to control what happens when. So you definitely want to have a general idea that there is an application stop first, right? Then there's before you install, there's after you install, there's an application start, and there's a validation section. Okay. This YAML file, it's just a YAML file. It's very proprietary. It is using AWS DSL. So you have to like look at the documentation to see how it functions, but it's not super complicated. Here's a sample CI/CD pipeline for containers. Here we've got code commit and code pipeline, right? Basically writing out some CloudFormation and some code build changes to either the ECR registry where the containers are pulled. And then CloudFormation is triggering ECS to go pull new images, right? So you get a new version of your Docker container out there on ECS. Remember that I said this. If ECS is not pulling down the latest copy of your image, you have to restart the ECS agent. I only tell you that not because I want you to know that personally, not because I want you to know that professionally, but because they are going to ask a question about that. It's probably going to come up on your exam. Hey, the image isn't pulling the latest thing. What do you do? And it's like one of the answers is to restart the ECS agent. I would have never have gone to that, honestly. I would have never thought, hey, the agent must not be working because it's not pulling the latest version, but it's still running and everything's good, right? But AWS actually considers that an official answer on the exam of like, hey, it's not pulling the latest image. You need to restart the ECS agent on your boxes.
So in this particular diagram, even though it is what it is, what is the conventional part of CI/CD? Is it up to putting things in ECR?
When you say conventional, define conventional for me, Saif.
Imagine we're doing CI/CD and the application should be running in a container. Should we deploy it in ECR and then it will automatically go to ECS, or like there's another step there that every time we deploy, we need to do that?
Yeah, so just because you update the container registry doesn't necessarily tell the system to download like the new copy, like a fresh copy. The ECS system is not polling the registry for new versions.
Okay, so that needs to be triggered.
It needs to be triggered. Yeah.
Okay.
Yeah.
And why the CloudFormation is going to ECS directly?
Because it's triggering a new version of release. So it's not a creation CloudFormation, it's an update CloudFormation.
Okay.
In other words, it's taking an existing stack and that has ECS included and saying, hey, I need you to deploy this new version of this app.
Okay.
Because
So
in
it is-
CloudFormation, you would have the task definition.
So looking at this diagram, it's like you build it, push it to the ECR, and then CloudFormation is saying potentially that, hey, there's a new version. Push that new version to ECS.
Well, the funny thing is all you have to do is just say there's a new version. In other words, let's say it was 1.3 and it switched to 1.4. If you updated CloudFormation with the number 1.4 and you didn't change anything else about the task definition, when you updated the stack, it would basically go out and figure out that the previous version was 1.3, see that there was a 1.4 that you wanted to now declare as the end state, and then it would force it to go grab 1.4 out of the ECR.
But not concurrently, because look at as I interpret the diagram, both things happen at the same time. But wouldn't you need to update ECR first and then kick off the CloudFormation?
Yeah, code pipeline would actually do
Figure
that
that out.
in order, right? Code pipeline would do the build first before it triggered the update.
Yeah,
You would specify that in order, right?
right. Yeah, this is the diagram here makes it not quite as,
No, yeah, there's an order to these things, right? Code build would run first and then it would push to CloudFormation. Yeah, because otherwise, if you specified a 1.4 and then it wasn't actually in ECR, the application would crash.
Yeah.
Yeah, so. Okay, next slide is a little more complicated, right? So here is like all of the details of what code pipeline would be doing. And I feel like, Saif, this probably speaks to your question just a little bit, because you're like, hey, there's no conventional CI/CD in this diagram. Where are all the tests happening? How's the integration happening, right? And so this is where like the building and compiling and the unit tests and the packaging, this is where code pipeline would be like orchestrating all of this, right? And so same thing, by the way, if you're doing infrastructure as code, you're still going to be, validating templates, generating artifacts such as AMIs and Docker images, right? In this case, automating the deployment and then updating the infrastructure stack to do that. So, yeah, so it kind of like shows you kind of like how this is applicable both for infrastructure and for software, pure software engineering. Notice that artifact repository could be code artifact, or it could be JFrog's Artifactory or Nexus or whatever you decide that you want to use. Version control will be the same thing. Could be code commit, but just to be clear, code, like code deploy and code pipeline, for example, will talk to GitHub and it will talk to GitLab and it will talk to Bitbucket. So, while the integrations are tighter with the AWS native services, it will talk to other services. Okay. Now we're going to talk about deployment models, right? But I got to tell you, the code services are pretty easy, with the exception of CodeStar and Code Guru. The rest are all named for what they do. Code commit does commits for Git. Code pipeline is a pipeline orchestrator. Code build builds. Code deploy deploys. Code artifact artifacts. Is that even a verb? Anyway, it hosts artifacts, right? So you get the general thing. So the code, to me, as far as like understanding what the code services do, it's actually pretty easy because the names are pretty straightforward. Code Guru and CodeStar are the only ones where I'm like, Yeah, I remember when I ignored CodeStar for the longest time because I actually didn't really understand it and I didn't have a need for it. But it does actually stand up in an orchestrated end-to-end developer flow if you need it. So it's really for the developer experience. That's what CodeStar is for. CodeStar is really just so you can create an enhanced AWS-based developer experience.
the developers are your stars in a team sense.
You're gonna go far, Brad. Keep talking like that.
I
Keep
have a
talking
simple
like that.
brain. I need to find ways to remember.
Yeah, just say that around a couple of developers. They'll love you. It'll be good. It is actually still about the developer experience even now. So, all right. So the deployment models, this is a kind of a continuation of the previous discussion because there are a lot of questions on this and it's kind of ridiculous. And by the way, they do it for Beanstalk and they do it for code deploy. So if you're not familiar with Beanstalk stuff, I don't even know that Beanstalk is in here. So you heard me say it. If you have not looked at Beanstalk's deployment models, you're going to want to look at those as well, because they are going to ask you questions about that. But we're going to talk about code deploys here for a second. A lot of these overlap, so the general concepts between code deploy and Beanstalk apply, but Beanstalk won't do all of these deployment models that we're about to talk about. Okay. Now you might say, okay, awesome, Michael, thank you for the buffet of deployment strategies. Here's the distinction. These deployment strategies, the problems they're trying to solve by approaching this with different strategies is, am I going to start new infrastructure and keep the old infrastructure, right? Meaning, am I going to replace the versions that are there, or am I going to start whole new infrastructure and add the new versions to that? The other consideration is, am I going to cut over, like completely cut over to a new version of code, or I'm going to slowly cut over to a new version of code? So those are the two problems these strategies are trying to solve is, am I just going to wreck it and just dive into the deep end of the pool and let's just go to a new version, right? And then maybe I'll keep the old version. That's one strategy, or maybe I won't, which is another strategy. Or You know, am I gonna like forget about creating a new infrastructure? Let's just replace everything there in place. I got 10 servers. We're just going to replace every single server one at a time with the brand new version of code. If I have to roll back, you know, forget about it. It's not, we make perfect code. It's never going to fail, right? So let me talk about these in detail, right? So in place basically says, I'm just going to replace the version. If I got 10 servers out there one at a time, I'm just going to replace, well, it's not even really one at a time, just so we're clear. It's not one at a time within place. Within place, it simultaneously just downloads and replaces every single old version with a new version. As you can imagine, what do you think the risk factor is here? Do you think the risk is high or low that you're going to have an outage? Right? Right. So just so you know, in place, right, it's just going to take the existing instances or Docker containers and it's just going to drop them and replace them. It's not even going to try and maintain uptime. It doesn't even care, right? So an in-place upgrade is the quickest way. It is the quickest way to deploy an application, but it's also the riskiest in terms of like, you're not going to have any failover or redundancy, right? A rolling deployment does the same thing, but instead of doing it all at once, it's actually going to do it like a certain portion at a time. Are you following me? Same 10 servers, but instead of just like, hey guys, we're all going to update at the same time. Instead it says, hey, you know what? I told you I only want 10% of my system down at a time. I've got 10 servers. So it's going to upgrade 1 to version 1 to 1.2. It's going to upgrade 2 to version 1.1 to 1.2. And it's going to do them one at a time. And it is actually going to check to make sure that it's working, right? So this one has a much more reduced risk, but rolling back is still painful. Why? Because you overwrote the existing servers with the new version. So you got to stand up new systems or uninstall. But yeah, right. So it's the risk is lower, but still not cool.
And still 1-to-1.
Yes.
You're overriding it. So rather than, you know, that's the difference, I think, between the rolling and the blue green.
Yeah, that's exactly right. So the difference is that once we get out of rolling, what's happening is we're now adding additional infrastructure. But here's the distinctions between immutable and blue green, right? With immutable, we're adding a box, we're rolling that box to a new version, and then we're adding that box to the mix and we're removing the old box. And so we're doing that one box at a time, right? So we're basically standing up new infrastructure with the version in question, right? Now, how the immutable is executed can be very big because blue-green can be considered kind of a variation, but typically we're standing up new infrastructure and we're putting a new instance on it. We're getting rid of the old instance. Blue-green, we are standing up an entire infrastructure. So I've got an entire, all 10 servers set up in blue, and I've got a whole other set of 10 servers set up in green, right? And what I'm doing is I'm literally cutting the traffic over. Don't be fooled though. Immutable also sets up 2 environments, but they're not complete copies of each other. So in other words, think of me, if I've got 10 servers on 1.1 under immutable, and I put one server onto 1.2, I'm going to remove one of the servers in 1.1. If I take a second server in 1.1, I'm going to add a second server in 1.2. I'm going to remove that server in 1.1. In other words, it's like shifting sand. You're gradually pouring your application over with immutable into new infrastructure, but you're not using the same boxes. You're using new boxes. With blue-green, you're like, no, I've got 10 new servers. I've got 10 old servers. We're cutting DNS over. We're done. We're going to the new version. Everybody, all the traffic goes. And by the way, you can do canary and other variations of blue-green, but it's a cutover methodology, right? It's not a gradual pouring of into new infrastructure. So blue-green is also the most expensive model because you're standing up your entire production infrastructure again, right? Everyone follow that? If you got 10 servers in blue and you create 10 new servers in green, you're going to have both running at the same time.
But isn't blue green the easiest to roll back?
Oh yeah.
Yeah.
And actually
Because
immutable is not as easy as blue-green, but it's easier to roll back than say the other two, Because let's say that you get halfway, so you got 5 servers on 1.1, you got 5 servers, and you're doing immutable, right? You got 5 in 1.1 and 5 in 1.2, and all of a sudden you realize that 1.2 is a horrible dumpster fire of an application and you need to roll back. What happens is you just start adding instances to the group and you start rolling your traffic back. And so you still have instances available to take traffic if you're doing immutable, but it's not as much of a safety net as it is with blue-green.
Michael, is that not the rolling style?
I'm sorry, say again?
No, what you explained now, is that not rolling rollup?
Well, rolling is an in-place update. Immutable adds new infrastructure,
Okay. Yeah, okay.
right? So in-place and rolling replace the existing systems, right? The difference is that in-place does it all at once and rolling does it one at a time, does it not?
Okay.
Or whatever percentage you specify.
Yeah. So the rolling, we will have a mix of different versions, right? So 10 servers, 5 may be with a different version and 5 with the old version, right?
Right. In other words, both rolling and immutable, you could have both versions in place, like running at the same time. And that can be a problem if you have a versions that are incompatible with each other.
Okay. Yeah.
With both in place and blue green, if you have versions of your software that are incompatible and cannot exist at the same time, you don't have that problem. The problem is that within place, you run the risk of it not working. And so rollback is harder. With blue green, rollback is easier, but it's more expensive. It also takes longer.
Thank you.
Yeah.
The review question had a question about blue-green, and in the additional information made a point that your green was your old version and your blue was your new version. And I'm seeing here AWS apparently does not make that point, given that the blue is the old version. Any thoughts on that?
I
People
mean,
have a standardization of that.
people forget. And I remember actually reading an article on this recently, and I for the life of me cannot remember what they said, but blue is typically considered to be like the old version. But
Interesting.
yeah, honestly, I think we all know there's an old version, there's a new version. What colors we call it,
All right.
whatever. Yeah. So,
Okay.
the only other thing I want to mention is that sometimes you'll see rolling with additional batch. So rolling with additional batch is interesting because it's kind of like adding an immutable variation into rolling where they add new infrastructure in. So that actually rolling with additional batch is an option inside of Elastic Beanstalk. So just know that that might come up. So please, I guess my bottom line is please look at the deployment models for Elastic Beanstalk if you haven't seen them. You will be asked questions. They match this, but Beanstalk has 1 or 2 more that do not exist inside CodeDeploy. So oddly enough, when you do a rolling deployment, by the way, you can say, hey, I want to only replace like a portion of them at a time. I want to do one at a time. I want to do half at a time. They usually call that a linear deployment, where it's like, you know, you want to do a certain portion of it. Or oddly enough, you can do a rolling deployment all at once. You know what that makes it? An in place. Right? I mean, yeah, because you're basically just saying, hey, I want to do it all at one time, right? So, what some people will do, by the way, just as a side note, is they'll expand the auto scaling group to have a larger number, more than the capacity that they need, and they'll do a rolling deployment, right? You know, people can approach this practically however they want. Immutable updates, remember, right? Immutable or basically disposable environment updates is if your application has unknown dependencies, right? So this just requires you to just replace instances, right? So you just add new instances and you shift traffic over to them one portion at a time, right? So for this this is also, by the way, known as disposable updates. I don't know why, but like in this example, you know, they're using code build to build the application dependencies and do all the stuff, right? And then they're going to use code pipeline to automate the testing in the environment. And then they're using an auto scaling group, which basically is adding instances and retiring old instances. So they're adding one instance at a time. So to Brad's earlier point, right? Blue is production, green is a parallel environment, right? So blue is considered to be the old version and green is the new version, but I've seen it in reverse as well. So so you basically route stuff from the old version, which is considered the blue version, to the green version. If you encounter any issues, you just roll back. This obviously requires either some kind of global load balancer or DNS, which is also very common, right? And so this type of deployment mitigates downtime and rollback a lot. So minimal downtime, quicker, safe, obviously additional cost resources. These are the things you kind of need to know, is that blue-green is the safest way to deploy and it's the most expensive. In place is the quickest way to deploy. It's also the cheapest, and it's going to be the one that's going to be the riskiest. Rolling updates have less risk to them. They're a little bit more expensive because you're going to be rolling. Well, actually not more expensive because you're not going to be rolling additional batch, but there's more risk to them because, or there's less risk to them because you're only rolling out a portion of the fleet at a time. With in place, you're replacing the whole thing at one time. And so, that can cause all kinds of problems. Immutable and blue-green are the ones where the costing options go up a little bit more because you're actually adding additional infrastructure. With immutable, you're only adding like 1 or 2 systems at a time. With blue-green, you're replicating the entire environment. So remember those distinctions. Immutable and blue-green are more expensive. Rolling and in place are cheaper. Rolling and in place have more risk. Immutable and blue-green have less risk. If you need 0 downtime, which one of these are you going to use?
Blue-green.
If you need to go as fast as possible, you got to cut your version over as quickly as you can because you can't use the old version. There's a complete incompatibility. Which of these are you going to use?
In place.
In place, yeah. The others are going to be questionable, like they're going to be variable. If you're like, well, I don't really want to pay for a full production environment, but I want the least risky option, then immutable is going to be your thing. I want to go as quick as possible, but I want to go as cheap as possible, but I also don't want to be as risky as in place. That's where rolling comes in. So rolling and immutable kind of fit in these gray areas, whereas in place and blue-green fit in extremes.
The canary would be coming in, would be characterized as a rolling.
So not really. So canary says basically, I have one version and I have a new version and I want to send a certain percentage of my traffic to the new version. There's actually 2 ways to do that, right? You can do blue-green, right? Where you have 2 environments, you got an old version, new version, and you send 10% of your traffic or 5% of your traffic to the new location and you keep the majority of it on the old location. And canary, the way canary works is that usually there's a small amount of traffic and then you go all in, right? You're like, I tested 5 to 10% of my traffic. It looks good. Let's just roll the rest of it over, right? That usually is a blue-green. You can actually do that with rolling with additional batch. And so that's why I mentioned additional batch, is because you actually are expanding the infrastructure like you would with the blue-green deployment, but you're doing 10% of your traffic to the new version. If it looks good, then what you would do is you would just roll it out. So there's 2 ways to do canary deployments. With either rolling with additional batch or with blue-green.
Okay.
All right, so we were on blue-green. So here, by the way, notice there's 0% traffic versus 10% traffic. This is a great place where you could like do canary, like let's just put 5% over here and 95% on the left. Some people do what's also known as linear deployment, which is linear over time, which means every 5 minutes you move a percentage of traffic over to the new version. So 10% goes in 5 minutes, 20% goes in 5 minutes, so on and so forth. Google, or the company, actually does that a lot when they roll out new versions of their products, like changes. They'll do this kind of A/B testing where they'll roll it out over time. And as long as it keeps being successful, they'll keep moving the rollout forward. And that's all automated, by the way. So their system automatically checks for error logs, because as you can imagine, they're deploying at global scale, right? So they do a percentage of time. So they can have a number of changes actually all being rolled out at the same time. And they'll do it like 10% every 20 minutes and then they just keep going from there.
So they control the percentages via the global load balancer.
For them, it's a global load balancer. It's not DNS. So you're absolutely right. All right, blue-green actually does require DNS. It does require a load balancer. I would say global accelerator could be a good friend here, by the way. Although global accelerator doesn't necessarily offer that level of control yet, but they're moving towards that. And then of course, auto scaling is important here because you want to be able to add and remove boxes as needed, right? Notice here's a, like almost like an example of a canary deployment. 10% on one side, 90% on the other. Oh, hey, there's linear. I knew it was somewhere in here. Linear's in here where you just, it's increments over time. And then all at once, again, if there's application incompatibilities or you've made major changes, all at once may make a lot of sense, right? The great thing about doing all at once with blue-green is that if you get into trouble, you just roll it back to the previous version. I remember the first time I did this back in 2014, 2015. I remember the CTO was so excited. He was like, wait, we can roll back to the other version without any downtime. I was like, well, hold on. There's going to be some downtime, but it'll be a second or two. He was like, oh my God, who came up with this idea? I didn't. So here, by the way, is a different weighting, whether it's 40 or 60% traffic, right? So if you have no issues, you just keep increasing the percentage. And then, you know, eventually if there's a failure, right? And I'm not talking about one box like this, it throws me out. It's like one box has a failure. No, if there's a code problem that prevents this application from going forward into production, then you roll the whole thing back, right? And there you go. Now, I got to tell you, one thing they talk about with immutability also is that like blue-green deployments with a database. So people talk about how you can't have a database, like multiple databases with your blue-green deployments. And that's true if the databases are not replicatable. In other words, if you have an RDBMS and you have no way to sync two versions of the database because they have different schemas or whatever, yeah, just know that like when you have to think about what your database is going to do in these situations, right? If you've gone in and made major changes to a schemaed database, you know, just know that you need to think about what you're doing here. Typically, the recommendation is that version 1 and version 2 can share a database that you know that can get like changed. Maybe you got a new table, or maybe it's Elasticsearch, and so you got a new index or something that you can use. So typically, if you're not using the same database, blue-green is not considered an appropriate deployment type. Because remember, one of these is still taking production traffic. So you want to not interrupt that. So if you share the same database, that makes it easier. The bottom line is that you got to think about this when there's a database involved, right? And the type of database makes a huge difference. If it's a NoSQL database, you're going to have an easier time. If it's an RDBMS, you're going to have a tougher time.
So regarding in the blue-green deployments, right? People, the new set would be in a different availability zone.
Not necessarily. Ideally, your production environment on the left, the blue one, is already across 2 or more availability zones. So your new set would also just be across the same availability zones.
Okay.
They might be in a different auto scaling group though.
Mm-hmm. So so that means we cannot use DR sites as the blue-green model, right?
You could.
Okay.
If you're using DNS, you definitely could. If you're using global accelerator, you definitely can. If you're using like a load balancer with an auto scaling group local, no, you can't do that. Load balancers, ELBs are local to a region. So. Yeah. The other thing to consider there is that what's going to be the impact of your users if you switch to a different region, right?
Yeah.
So, but you could. Oh, and by the way, Amazon just released their data center migration thing called Cloud Endure. It's a company they bought a few years ago. They can actually literally run agents across all of your systems and migrate you over in real time over to, like, after there's been some replication over to cloud. So if you haven't seen that yet, if you ever need to move somebody from their data center into AWS, and the reason I mention that is it's kind of like this model. They run an agent that basically copies your entire block by block operating system up into AWS. I haven't used it yet. I mean, I've used Cloud Endure actually, because they've been around for years, but I haven't used it since AWS bought them, but it sounds pretty cool. That is a complete lift and shift model, but it sounds like that might ease, migration for people who are struggling. Okay. ECS works the same way. You can launch new versions of your containers / tasks / whatever you want to call them, your applications, and then you can just cut over to the new versions, right? So the load balancer, by the way, can like handle that, right? Because containers, by the way, make this easy because containers are immutable by default. So you're going to end up standing up new containers to roll over anyway. You can't do an in-place upgrade with containers. There's no modifying containers over time. If you need a new version of a container or you want to modify the configuration of a container, you have to deploy a new container. That's immutable infrastructure. And people are starting to do that more and more, by the way, with their virtual machines. Instead of migrating the virtual machines over time, they have a configuration manager that configures the virtual machine a certain way, packages it into an image. And if you need a new version of your virtual machine, you deploy a new version of your virtual machine with the new changes, right? Now, of course, that only works if you have a load balancer in front of the machine. You wouldn't do that for something that where the users are directly accessing it unless you could take the downtime, right? So since containers, by the way, stand up in seconds, typically, people are not super concerned around the downtime. It still provides a bad user experience, but as long as you have a certain number of containers up, the load balancer is going to feed traffic to those containers. So your user will never really know that you suffered an interruption. So just keep that in mind. Is that since containers boot so fast, if you have 10 containers standing up 5 more at 40 megs a piece, doesn't really matter to most organizations. So with containers, like these kind of deployments get a lot quicker and easier.
The provisioning though seems to take a while, what I've noticed for some of our deployments.
Provisioning of
The containers or the tasks to get them to go into a ready state.
really?
Yeah,
You mean on the load balancer or just on the ECS cluster itself?
ECS cluster.
What kind of containers are you running?
It could be like a pre-built image from a Qvera is one of them. It's commercially available on Docker Hub that does ETLs for HL7, and then some of them would have been also just kind of homegrown images for our own API backend. And maybe the Qvera one is, I'll have to compare the difference between our homegrown API. I think those seem to provision quicker than what I've noticed with the Qvera.
Yeah, if there's a lot of external dependencies, that might slow it down. What I might do is take it off of ECS and like run it locally and see if it will provision faster, just to isolate whether or not it's ECS or whether it's just got too many dependencies to talk to.
Gotcha. Okay.
Yeah, but typically, even with databases, like I've seen them start, under 60 seconds. So if they're not doing data validation, they're trying to validate their entire data set, that takes longer. Like Elasticsearch will sometimes get in these weird states where it's like, I'm going to verify all 10 terabytes of data before I actually launch. And I'm like, what? No, don't do that. Yeah.
Okay.
Yeah. So I would test that actually, Brad, because it shouldn't be doing that normally. Yeah. Like if I launch Nginx, for example, right now with a full configuration and a bunch of read writes and whatever in it, it'll take like 15 seconds to start.
Okay.
But that's pretty stateless.
Yeah.
So here's a blue-green deployment with co-deploy and Fargate. So the previous one was ECS. This one's just like Fargate, right, on the tasks. Notice here that the application load balancer is just going to roll from version 1 to version 2, right? So earlier you were like, why are they using a classic load balancer? This is where I don't know, right? Because they could have just used an ALB or an NLB because it actually does work. Now, both load balancer types allow dynamic host port mapping, which means you can place multiple tasks, multiple containers on the same port on a single container instance. So just to say this is that the load balancer will figure out when there's a new version once it's deployed and added in, and you can just have it roll over, right? So I don't know why we use classic in our lab example. So here, by the way, the production traffic is going over to target group 2 instead of target group 1. Everything's rolled over to the new set, right? And that's just you changing the listener, really. So if you get into trouble, you just roll back, right? Drain the blue of all the tasks, and then you're done. You just roll it out. So this blue-green is very much possible with ECS and EKS, actually. So again, I already took a note, by the way, send them a quick note. Hey, can we just convert that over to ALBs? They probably already have that in the works. Okay, here's the last thing we're going to talk about. Stack sets. I'm just going to skim this one a little bit because quite frankly, they're just going to ask you, do you know what stack sets do? They're not going to ask you to code one. They're not going to ask you to like blah, blah, blah. They just want you to understand the concepts of a stack set. This is all CloudFormation related. Before I get into this, is there any questions about CI/CD, about, the code services that we talked about, or just the general idea around in place, rolling, immutable, and blue-green? Okay. All right, we want to deploy infrastructure to multiple accounts or even just deployments, right? Didn't have to be that. How do we do that, right? So we saw this one before where we had CloudFormation in play, right? Which basically it was doing the triggering against ECS. Well, what if we really have a best practice set of ECS clustering that we're using, and we want to push that to a bunch of accounts, whether they're in an organization or not in an organization? Is there a way for us to push these CloudFormation stacks out to for other accounts to use, right? Well, the answer to that, of course, is yes, right? Because we want to apply good software engineering practices to our, infrastructure as code. And so having that repeatability and reusability for stuff that's been tested is perfect. And so this is where stack sets come in, right? Stack sets allow you to take an admin account. So let me be clear about this. There's the publisher admin account. And it creates a stack set, does all the testing, makes sure the whole thing is rock solid, blah, 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 blah. And then what happens is it publishes to target accounts. Now, in order for it to do that, by the way, it has to have like a role permissions to the account, or it needs to be part of an organization that has permissions, right? And so what this then allows it to do is that without CloudFormation stack sets, you're going to have to deploy these stacks manually yourself. And if you want to make an update, you got to update them all manually. If you use stack sets, you have an administrator account that is the publisher account, and it publishes a stack out to all of the other target accounts. And so when you update it in the publisher account, it automatically updates it for all of the target accounts. Please be careful with that because you can break things. That's always true. Remember, Spider-Man said it best, with great power comes great responsibility. So remember, if someone tries to rob your former wrestling coach, just go ahead and punch him in the face. Sorry, that was advocating violence. Let's not do that. So stack sets allows you to basically replicate this infrastructure out, right? And that's what you want, because it's not really about control. It just like saves so much time and headache for the people who don't want to know how networking functions. They just want to run a cluster. They don't want to have to figure out how a cluster works. So just give them a stack set. Let them just kick the stack set off, and then they can follow your best practices and yet get the services they need, right? Now, the permission model for stack sets is interesting. And I don't know why they call it self-managed and trusted access, because it's usually referred to as self-managed and service managed, but whatever. Just know that you have two names. There's trusted access and there's service managed permissions. Self-managed access means that you're going to have to create the IAM roles required to deploy the stack sets on each of the target accounts. You're going to do it manually. Doesn't that sound like fun, right? So these roles are necessary because if you're in an admin account and you're publishing out to a bunch of other accounts, you're not an organization. You don't have any relationship with these accounts. So the roles are going to be necessary to establish a trusted relationship that allows you to push these stack sets out, right? That's manually. If you are part of an organization, right, you don't have to create the necessary IAM roles. When you create your stack set, you can say, Amazon's very kind and says, hey, would you like for me to create the permissions necessary for you? And you check a box, and guess what? It creates all the roles for you, so you don't have to do it manually, right? And by the way, if you can actually enable it to automatically add the deployment, if someone adds an account to your organization, they'll automatically get access to the stack set. So you don't have to go out there and redeploy the stack set. Every time you add an account to your organization, the stack set will be added automatically to the new account that's now part of your organization. Right? So you don't have to worry about having to go back and reprovision stack sets to these new accounts. Hey, we just added 5 new accounts. Oh, I got to go back in the stack set and redeploy. You don't have to do that. So if you're in an organization, stack sets will automatically make sure any new account has the stack sets that you've published to the accounts. Let's see, choose a template, make sure that all, like there's a line here that says ensure all dependent resources exist, because if you create a stack that relies on other stacks, like let's say you create an ECS stack that requires a networking component, I want to make sure that exists, right? Then you create the stack, you monitor the stack creation, and then you configure the tags and the OUs and specify the regions, right? So it basically allows you to use that single CloudFormation template to create the stack, right? Now, stack set operations that you can perform are either creating, updating, or deleting. When we were back earlier looking at where CloudFormation was triggering ECS, all that CloudFormation stack was doing an update. I'm changing from version 1.1 to version 1.2 of my container. That's all you're telling ECS to do, right? So a stack set is a regional resource, by the way. So you have to push it. You have to go into other regions if you want to push it, right? So if you create a stack set in one region, you can't see it in other regions. They're region specific, right? Create, update, and delete, or delete the stack set. Here's some best practices to think about with stack sets. 1, ensure that your resources are not going to have global conflicts, especially those S3 bucket names. You know, people joke with me all the time. They're like, why do you have goat in your like bucket names? I'm like, because who names their buckets goat bucket? Right? So, you know, it's not, it doesn't just mean greatest of all time, which I just found out that by the way, Dave Chappelle has a special and was talking about being the greatest of all time. I was like, I had no idea that GOAT stood for greatest of all time. I just thought that was funny. Anyway, you can store your, one of the other best practices is store your CloudFormation templates, just store them in S3 buckets, right? That way they're available to everybody who's using the stack set, right? Make sure that you remember that updating a stack set updates all of the instances of the stack, right? So be mindful that you've pushed this out to across a bunch of accounts. It's a template, right? So if you update the stack set, it's going to update it for all of the other stacks that are out there in use, right? By the way, there are deployment and rollout options for this, like, you know, maximum concurrent accounts. And in other words, you can control how you actually roll this out, oddly enough, much like you can with deployments and code deploy. Please make sure you test. You know, we're infrastructure engineers. I've been hacking coffee makers since I was 19. That does not mean I should not run tests. I remember the first time someone made me TDD, I thought it was going to slip my wrists. But here's the problem. Now I write tests before I write code. And guess what? The quality of my code is usually higher because I'm writing tests first, right? I don't do that for everything, but just know, like, please test your stuff. And then remember, you can only perform one operation at a time. In other words, you can't like update a stack set and then while it's in the middle of updating, decide you're going to delete it. It's got to finish updating first, and then you can delete it, right? So just know, right?
Do you have any examples of like a stack set application or use case? Networking kind of comes to mind if you want that kind of rolled out as a common thing, or different types of network.
I would say anything that you're going to offer as a template could be a stack set. For example, let's say you want to offer a very specific set of EC2 instances and you want to put them in the service catalog. That can be a stack set.
So these, okay, that was the follow-up. Then stack sets get deployed to your service catalog. They don't necessarily get implemented on the other accounts. They could be.
Oh yeah. No, they show up in CloudFormation as a stack set option, but you could also use it to automatically provision. Like they could use it to provision their service catalogs as well, right? Because remember, this is just CloudFormation. So this isn't going to show up directly in Service Catalog, but a Service Catalog administrator in that account could then pull that stack set into the Service Catalog and say, hey, we now have modified our Service Catalog and we only offered 5 virtual machines, but the company just whitelisted like 10 virtual machines. And so the Service Catalog administrator can now update and pull in that new stack set and say, our Service Catalog now has 10 machines in it. And that can be done on a per account basis. Because remember, the administrators of the accounts could be their own project or their own business unit. So they themselves might not want to make everything available to everybody. But that's how you can push stack sets from a primary publisher account to a bunch of member accounts. And then they then can control themselves what is available to everybody.
Gotcha. Okay. I thought
Yeah.
this was like auto installing XYZ things across all those accounts, which seemed a little problematic, but this is saying, here's our best practice desires. You guys can decide whether or not it fits into your
Exactly.
business case.
Yeah. In other words,
Okay.
you can actually have it so that here are our best practice templates. You can now launch these, right? To make sure these resources are available.
Is it possible to use the stack sets to create a new environment? For example, I have a dev and production environment. I want a dev 2 environment.
No, you can. Remember, it's a little bit like Docker images, right? You can launch whatever copies of it that you want to.
Okay. So I need to specify the new target account and then I will go to target. It creates the same set of infrastructure in the new environment, right?
Right. Well, remember, since this is CloudFormation based, you can actually make CloudFormation ask you questions before it will let you launch. So for example, you could say, what do you want to label this environment? You could say, dev 1. And then you could launch another stack set with CloudFormation and it's going to say, what do you want to call this environment? You can say dev 2. Right.
No,
So
if
you can customize it at launch time.
Right. If you're targeting multiple accounts, so targets from the publisher account, you go to different target accounts, say two or more, right?
Mhm.
So it will. How do you specify the labels for each one? You specify.
No. When someone goes into CloudFormation and launches the stack set, you can ask it to ask you questions, right? You can actually force it to ask questions, or you can do it based on account number or any other kind of tagging that you want. So in other words, you could do it programmatically, or you can make it a manual process and say, hey, ask the user who's launching this what they want to call it.
Okay.
Yeah. So you can control it in a couple different ways. Obviously, programmatically means you have to actually be able to pull it from somewhere, either a list, maybe a tag on the account, or some other thing that's unique to that account.
Yeah.
But if you're using just straight up CloudFormation, you just use parameters like Sham just posted up into chat, right? Is that parameters basically are questions that CloudFormation is going to ask the user, or you have to submit on the command line that you have to answer, although some of them are optional. If you specify that you have to answer, including things like labeling, tagging, what network is this going to sit in? Like you can ask questions in CloudFormation of like, what are my dependencies, or what do I want to label this?
Okay.
But that's a fundamental CloudFormation thing. That's not just a stack set thing.
Yeah. So what is your experience? So people prefer Terraform or CloudFormation?
Zoran, I gotta tell you, you're asking the wrong person because I love Terraform. Like, I think Terraform's the bomb, right? That being said, I think you need to know CloudFormation. I think you need to know Azure resource templating. I think you need to know the Google equivalents, right? In order to really do Terraform well, right? I think you actually do need to know a little bit, but I like Terraform, right? And I like having one tool to actually like do all that with.
Mhm.
But that all being said, I prefer to do it in code, right? So Terraform has its own proprietary, domain specific language. And quite frankly, you can't do programmatic. There's a couple of programmatic like operators and flows that you can do in Terraform, but they're not as complete as you can do it like Python, right?
Yeah. Mhm.
So, I think Terraform is the industry de facto tool for provisioning across cloud providers. And I think the whole industry reflects that. But if you're a programmer, I think you're not going to prefer Terraform. You're going to prefer something like, I think Brad just posted in as well, CDK, Pulumi, Crossplane. You're going to prefer something that allows you to manipulate the thing directly. But for the rest of us, Terraform is probably king.
Yeah. I couldn't figure out the cloud formation. So, my learning curve for Terraform was very smooth, but cloud formation, I had some challenges.
My main pain point with Terraform and well, with CloudFormation actually, with main pain point with CloudFormation was manipulating operating systems. That cloud init section inside of CloudFormation is just hard. And I know Chef, Puppet, and Ansible really well. So instead of using CloudFormation or even Terraform for that, I'll actually call Ansible and just let Ansible do the configuration. So I think everybody, just to say this, everybody needs a provisioning tool, everybody needs a provisioning management tool, and everybody needs a programming language. So I think, you know, even nowadays for infrastructure engineers, I think you unfortunately need to know both. I used to resist programming other than, you know, scripting for so long, but now it's a requirement. So everything's API driven now.
Right. I look fondly about the old times, right? So everything's on the code. We just blame the coders, the developers, and then you just install and then configure.
Yeah, so you could start a whole podcast about the good old days, and I bet you would have a large following of people who'd be like, "Why do I need to code?" They would absolutely like love following your like stories. So yeah, I agree. Because you know, back then it was okay to be called a system administrator. Now you're a pariah if you call yourself a system admin. So okay, knowledge check. What are the key metrics for evaluating about whether or not your CI/CD model is amazing? You like my little modification? What are the key metrics that we're looking for, like to evaluate the results of a CI/CD model, right? I'm sorry, I just noticed the last one. Yeah, so number of developers required for a project, that's definitely not on the list, right? So increased, you know, velocity around frequency of deployment, decreased lead time, so what they call the mean time to release from commit, right? And then of course an increased success rate or a decreased failure rate for deployments. Those are actually, two of those are right out of the DevOps handbook actually. So yeah. All right, what are valid deployment targets for code deploy? In other words, which of these can code deploy actually run against? Some of these are integrations, other of these require an agent. Which of these actually work? I love how you guys are exclusionary. You're like, look, not Edge, not that one. Yeah. By the way, whether it's snow cone, snowball, or snowball edge devices, yeah,
Snow
you're
machine.
not. Say again.
Snow machine.
Wait, is there really a snow machine?
Yeah, I believe so. I think it's like the biggest one.
Oh no, the snowmobile. You're thinking of the snowmobile.
Snowmobile. Yeah.
Yeah.
My world is the snow machine where I come
Yeah. Yeah, you know, probably a good name. Yeah, so those devices you can't really touch. By the way, I was there at reInvent in 2016, and that truck, by the way, followed us everywhere. I felt like I was in maximum overdrive. It would just show up on the floor. It would show up they drove it on the stage for presentation. It was really weird, honestly.
I
Anyway,
saw the video of it here.
so strange. Snowball Edge is the one, right? So just note, by the way, it integrates in with Lambda, ECS, and anything that can run an agent. So if you have EC2 instances or on-premise instances, you can run code deploy. Okay, which of these is actually an orchestrator for events like building and deploying and committing inside a CI/CD pipeline? Oh, Shyam, just one thing, be careful because the snowball and snow cone systems are no longer just for data transfer. So they're now considered edge devices, and like some of them have like 96 cores and like terabytes of storage, like way more than 80 on them. So just be mindful, Shyam, that the snowball devices are no longer just for data storage. There are now compute versions of them as well, just so you're aware. So the answer to this one, by the way, is code pipeline. And I only mentioned that, Shyam, because I had to change my mind recently because I thought they were just storage devices. And I actually had somebody order one of the edge devices and it had no storage on it. It had 8 terabytes of storage, but it had tons of processor. So they've really shifted that around, the snowball family. So code pipeline, remember, is the overarching orchestrator, right? So this is the one that will orchestrate pipeline, build, artifact, and commit. So what's the use case for edge device?
For
Factories,
the
planes.
processing.
Oh.
Yeah, for the processing power, you just need something temporary and remote.
No, so imagine you got a building with like 5,000 sensors in it and you're wanting to get data from it, but then you want just the aggregates. So
Mhm.
you get the numbers, you crunch them in real time, and then you ship them up. And so the 8 terabytes of space is just there, has a scratch drive.
Gotcha.
Yeah. Airplanes, same thing. Although airplanes tend to retain their data, so that doesn't work, obviously. They have other devices that have more storage, but that's the use case. Any edge, we're in space, we're underwater, we're in the air, we're underground, we're flinging, bowls of hot molten metal around like in a plant. So those kind of things. What are the benefits of using CI/CD with infrastructure as code? Think of everything that you would get if it was like you were a software engineer, right? Yeah, good. Yeah, A, B, and C, right? So no need for code templates. That's so weird to say that. You still actually, matter of fact, the whole reason to do infrastructure as code is actually to have templated reusable resources that you can share with your friends or your coworkers, right? Although I've never had a buddy ask me for a Terraform template, which is just sad. Breaks my heart a little bit. I know, right? Ask me for a Terraform template. Anyway, so it doesn't eliminate the need to code templates because actually that's still a process. But the rest of it, as far as like centralization, version control, automated validation, like I gotta tell you, like the testing piece is great when you're doing infrastructure as code. They call you have templates. Brad, did we not talk about CDK? I thought we were all using CDK now. We're not using Terraform anymore, right? All right, what's the best practice with a backend database when you used to use blue-green deployments? I'm so glad I made a big deal out of this, right? What is considered the best practice if you're doing a blue-green related to databases? What's the easiest way to do that? Yeah, make sure that all of your database changes are backwards compatible because you're going to use one database. That's the best practice. You can get away with multiple databases. You just need to think about it a little bit more. But best practice is just use the same database and migrate it. Right? Or use a change control service for your database like Liquibase and others and track all the changes against your database the same way you track all the changes in code. So when I talk changes, I mean like schema changes, not database changes. Okay, so make sure all the database changes are backwards compatible. Good. Okay. That covered CI/CD. And I'm just going to forewarn you that I don't think we're going to have a whole lot of time today to cover questions. But I think like for the most part, you're set up around practice questions pretty well. So I'm going to go ahead and cover large scale. No, I'm going to cover high availability, actually. I'm going to cover high availability for as far as we can up until 1:30, and then I'm going to stop. Does anyone have any questions of any type around any of that we covered? I feel like somewhere in here is a link to the deployment models that I was going to share with you. Is that somewhere in these notes? I so rarely look at these notes. Bear with me 1 second. I want to see if I can get this to you. Hold on. I just want to make sure you have this before we move on to anything else. Yep. Okay, this is a good one. So this is a quick list of all the deployment models inside CoDeploy. And then let's go take a look at the deployment models for Elastic Beanstalk. Assuming I can spell Elastic Beanstalk. There we go. There we go. That's a good one too. So that's a little shorthand. So file these away if you're making a little notebook, just like make sure that you know like in general. No, so notice this says all at once, right? Which is basically in place, right? Rolling with additional batch, immutable, and then they have traffic splitting. I am shocked that they don't have blue-green here. Anyway, so, and then the old one that we were just looking for is, compare that with in-place deployment, blue-green, right? And notice they have blue-green through a variety of different like possibilities. I don't see rolling. Huh, interesting. It's interesting that they talked about the rolling and the in-place upgrades. Sorry, the rolling and the immutable upgrades, but they didn't actually offer like a code deploy. They're saying code deploy doesn't do that, but I know for a fact that code deploy actually does. So maybe this is something they've changed recently. Huh.
Does the document have when it was last updated anywhere on it?
Typically no, unfortunately. Huh. All right, I'm gonna do some research on that, figure out what's going on with that. Regardless, as long as you know the 4 types, right now they're saying code deploy only does blue, green, and in place. And that is just not true, actually. And then Elastic Beanstalk does that whole list, including rolling with additional batch, but it doesn't do blue, green, which I could have sworn it did, actually. That's weird, because that was the whole reason we did a blue, green deployment actually on Elastic Beanstalk a few years back. Anyway, regardless, that's why we look at the documentation. So there it is. So you understand the 4 general types, but make sure you look at these because they are going to ask you questions. When they ask you questions, they're going to assume that you know what the general types do. So when they say, hey, if you want to do an immutable upgrade, right? In this particular case, they're going to say, like with Beanstalk, well, that's possible, right? Here, what they're saying is that immutable upgrade is not possible. So you're going to end up doing a blue-green deployment, which is a form of immutable upgrade, right? So, all right, we'll get the answer to that. Regardless, you've got your 2 links to the official documentation, which is what we wanted to do. All right. Let's talk about high availability and distributed denial of service. So how do we maintain high availability in the face of security? This will be our epic last minute temple run for the last 30 minutes or so. And then, you know, again, this might be the end of your day, so you're done. So when you start back up in the morning, I would start working those questions. Remember, I want you to be methodical. If you get it wrong, peel back what the distinctions are and bring your questions. We can take the first part of class or the end of class to answer any things where you're like, I got this question and I sincerely do not know what the distinctions are. John told me what's wrong and why this is right. Let me know. And remember, you should feel remarkably uncomfortable about taking an exam a week from tomorrow. Okay. If we get to next, Monday and you're like not more comfortable, then you're gonna need to study some more practice questions and ask me more questions. Okay. Because that's what we want. We want you to be more comfortable and feel like you're trending towards ready by the time we end on Monday. Okay. If you do not feel like you're trending towards ready by Monday, let me know because we're going to need to carve out some extra time and we'll make that happen. Okay. All right. So I'm not necessarily going to ask these questions, right? All of these above are basically potential threats to an architecture. Just to mention this, most of the outages that you see that show up in the news are actually caused by human beings. So they're configuration errors. And I'm not saying maliciously. I'm just saying that, like, they threw a comma somewhere. I mean, how many times have you read the after action report or the root analysis and you're like, damn it, I put a comma in that S3 configuration and they didn't have a validator that like checked to see if commas were in there. I bet you they do now after they caused a global outage. So whether it's malicious bots, denial of service, or just app vulnerabilities in general, or configuration errors, these are all potential threats, right? Now, this is a good question. I will ask this one. Have you all ever had to defend against a denial of service attack or distributed denial of service attack? All right, 30-second story. I have, because a salesperson, when I was working for an advertising company, went to talk to somebody in Malaysia and bought a Malaysian click farm to come and generate false traffic against our site. He didn't qualify the amount or anything else, and we completely fell over because we had all these distributed data centers inside of Malaysia suddenly clicking manually because it all looked like legitimate traffic, right? Because it was actually users. It was people. It wasn't automated. It was just thousands of people all coming to our website at the same time. The guy walks into the pit while all of our red alerts are going and we're all sweating trying to figure out why all of a sudden we have 1,000% traffic against our system. He was like, hey, you think it has anything to do with the click farm that I just bought traffic from? End of that story. Okay, moving on. So we're going to talk about a web application firewall, which is a layer 7 web application firewall. These have been around for as long as XML has been around. Just kidding. They've been around for a while. So, and then Shield Advanced, which is an enhancement from Shield Basic. Every single AWS account has Shield Basic attached to it. What is that? It is a distributed denial of service mitigation service. Amazon's entire security team is constantly defending AWS from attack. Why? You know why. Because can you imagine the treasure trove of customer data that is out there if you were able to break through AWS's defenses and get access to, I don't know, let's pick Netflix, for example. Boy, I bet you they have some great customer profile data. How rich would that be, including credit cards and all kinds of stuff, right? Now I sound like a hacker. Anyway, the bottom line is that AWS has a pretty strong advanced, like a security team. So Shield Advanced is the paid for version where you can get cost mitigation and access to the team. Firewall Manager and Network Firewall. Firewall Manager is basically used to create standardized rules for AWS WAF. So for the web application firewall. So think of it as a management tool. Andrew, I was thinking you were going to type that you had to mitigate an attack a long time ago in a galaxy far away, but you didn't go for that.
But no, I didn't. I just went with a long time ago. And then I realized there's also a fun story about Georgia's contact tracing last year, but that involved somebody having a public Postgres SQL, which was the first thing that shouldn't have been there. But that's what they were hitting. And the quick fix was change its IP address.
Oh,
because it was literally just the cloud SQL that had a public IP that somebody was just banging against so much that nothing would work.
yeah. Databases aren't really built to defend themselves against the internet, so that's pretty cool.
It should have never been had a public IP, but that's a whole other world of 72-hour software development.
I had a friend who the other day was like, remember, friends don't let friends put databases on public IP addresses. I was like, that's true. Actually, that's a very geeky joke. All right, so today's session basically says, hey, InfoSec has some concerns about how we're running our architecture. We want to be able to block access with countries that we're not allowed to do business with. We need to mitigate distributed denial of service attacks. How do we do that? And then how do we dynamically respond to known bad actors who come knocking on our door, right? So there's some user stories, mainly from a security auditor, the CISO, and the operations manager, which basically says, how do we lock everything down? How do we make everything more secure? First is up as far as services that make sense for this is the WAF, right? So the web application firewall really is a traffic filter that basically just works on rules like regex, right? It says what's good traffic or what's bad traffic. If it's good traffic, you can allow it. If you know it's bad traffic, you can deny it. What are the characteristics? You could say, I don't want to allow traffic from like a specific country, or I don't want traffic that has like, drop production table, in the URL, little Bobby drop tables, right? For those who are familiar with XKCD. So this is what WAF does, is that, you've got these large systems that are good at simulating human traffic. They're really good at it, right? Because you only have to capture 100 people's behavior, and then you could just take that traffic and go tie somebody up with fake behavior where you're just dumping stuff into a shopping cart just so you can mess with Amazon, right? As an example. And so distributed denial of service attacks, by the way, just to mention this also, use a large number of machines. Their danger is that they use such a large number of machines, right? That all simulate human behavior. Or they do things like tie up the TCP IP stack by doing half of a handshake, right? To establish a connection. So here's some of the common attack layers to think about, right? Is that, this is obviously the OSI model, right? Which runs all the way from physical to data link to network, et cetera. And notice that there's different types of attacks at different levels or layers. So if we want to shut down someone's web server, let's just flood it with invalid traffic. Let's just like put a bunch of posts on it or get a bunch of gets or whatnot. We can also attack it from the side by hitting DNS, which is all layer 7. And then we've got a variety of attacks against both the TCP and IP layers, right? Either send floods, or like if you're using UDP, you could do some kind of reflection attack, right? To kind of like overwhelm at the network layer. So infrastructure layer attacks are usually done by shield standard, right? So shield standard, which is no additional charge, defends against this, and Amazon does this all the time. So you get it for free. And shield standard has some features, right? No additional charge, automatic defense against most layer 3 and 4 attacks, right? Baseline and anomaly detection. And so they're, as you can imagine, they're constantly watching AWS's infrastructure for problems and deviations. They also have like these proprietary like packet filtering stacks, if you will. They're constantly filtering out known bad actors. So this is just standard. Now, if you want to get to layer 7 though, and you want to go above the networking stack, and you're gonna have to basically pay for this device. So application layer attacks are going to be handled by WAF, right? So this is a web application firewall. It's going to handle 80 and 443 traffic, right? So HTTP and HTTPS. And it's meant basically to protect, like, in a sense, your business logic, right? WAF can stand in front of the following. It can stand in front of CloudFront. WAF can be put in front of an API gateway. WAF can go in front of an ALB. It can also go in front of AppSync, which is like GraphQL APIs, right? So WAF can cover and protect those devices. So application load balancer, API gateway, AppSync, and CloudFront. So, you can basically allow all requests except the ones that you deny. You can block all requests except the ones that you specify, or you can, like, basically count the requests that match the properties you specify. So the reason, by the way, you might do that is that you might do it because you want to count how many times this rule triggers, because you're testing a rule, right? So like you can actually set a rule to block all requests except the ones that match the rule. You can set it to allow all requests except ones that match the rule. Or you can just say, hey, I just want to see how many times this rule gets triggered. How many people are actually coming to me from the island nation of Sandovia, right? You're like, I just want to see how many people, right? So, because maybe Sandovia is a land of hackers, right? And you're like, I just want to see how many people are coming from Sandovia before I enable this rule that blocks all traffic, right? So just know you can choose from one of those following behaviors.
And then WAF and CloudFront have a little bit of overlap because you can also do filtering on CloudFront for geolocation.
That's right. You can do some country filtering, right?
Can you do
By
the
the
same country filtering then on WAF or not?
You can, but honestly, best practice is to use CloudFront for that.
Okay.
Yeah. By the way, that is a question on the exam.
Yeah, it's one of the practice questions. So it's,
Oh, yeah. Can CloudFront do geo filtering, basically? Yeah.
yeah.
So WAF is awesome because it's really easy to integrate. You just stand it up and it attaches itself automatically in front of traffic inbound to your devices. So it basically acts as an inline tap, if you will. So people won't see it. It doesn't have an endpoint, right? So it's not going to interrupt your traffic flow. It's stood up in front of your devices. So it stands up in front of the ALB, in front of AppSync, in front of CloudFront, right? As you can imagine, since it stands up in front of CloudFront, it is actually part of the edge services. if you follow me, right? Edge location, because it will actually stand in front of CloudFront. Got low overhead, great customizable security. You can also use pre-created rules if you want to. You can also get rules from the Amazon Marketplace if you want to, right? You can also, by the way, say if I see 5 of this type of behavior over a 5-minute period, do something, block it or allow it. So just know, by the way, that you can actually do it also over time. If there's like 10 instances over a 5-minute period, then you might block it. Like if someone like, I don't know, someone tries to access credit card information from a specific account too many times, right? So you can enable WAF, you have to create what's called these access control lists. You have to choose the resource, which is one of these 4 here, that you want it to filter requests for. And then once you have an access control list, you add the rules that you want, right? For that, for those resources in question, right? So you can specify like the IP address that, requests originate to or going from, right? You can specify whether you want to block them or allow them or just count them. You can create rule groups for your rules. So, and then you can define an entire action. Like for this set of rules in the rule group, I want to allow, and then, right, for this set of rules in the rule group, I want to deny. You can also specify a default action for the access control list in question, either block or allow, right? Trying to think of anything else to say about this. Oh, yeah, there are probably other things to say, but we're gonna leave that alone because it's probably not relevant for the exam. Here, by the way, you got a web access control list, inbound traffic, right? So like you could do, where your IP address is, where the request originates from, where the country is, values in the request header, length of the requests, presence of SQL code. So you can prevent SQL injection attacks, presence of a script. So you can prevent cross-site scripting. By the way, you can test for strings of any type using whatever regex, voodoo you want to use, right? So, by the way, you can dump data into Kinesis Firehose or into CloudWatch to get enabled, like detailed logging, right? Yeah. Here are the rule types, by the way. I mentioned that you can have built-in rules, right? You can get some rules from the marketplace. You can also, by the way, use CloudFormation templates basically to create, and this is done through something called security automations, which we're going to talk about shortly. But security automations can create rules for you automatically. What happens is that, like guard duty, for example, which is used to watch your VPC network, can be configured to automatically trigger security automations, which then talks to CloudFormation, which then writes rules based on responses. So if guard duty sees someone coming and doing malicious activity, you can actually set up security automations that will then update a CloudFormation stack, which will update your WAF with new rules, and it will block that malicious activity for whatever time period you want to specify. So you can automate your responses based on like real-time, like network flow or network traffic. Manage rules, by the way, right? These are the ones that AWS like provides, so you don't have to write your own rules, right? Notice that, if you want to turn on the Amazon IP like reputation list, which is where their security team is identifying known bad actors, you can do stuff like that. These rules, by the way, are managed by AWS's threat research team. So this is an extension of the DDoS response team that is part of Shield Advance. These rules are also influenced strongly by the top 10 security risks that are like in the OWASP community, right? So it's, remember, just to stress this, a WAF cannot in general offer you the full protection against all attack vectors in the top 10 list. So, Just realize it'll do a lot of them, but you need to add additional mitigations. Like, what if it's a DNS attack? Right? WAF's not going to help you with that. That's a vector, right? Something to keep in mind. Yeah. So there are three rule types offered here, right? There's a baseline rule, which just provides general protection against common threats. There's like a use case specific, which provides like incremental protection for things like, what was the last one I saw? WordPress, PHP vulnerability, like known PHP vulnerabilities, known operating system vulnerabilities. And then there's like IP reputation lists, like the one we were just talking about, where it's like, we're going to block known bad bots, known bad actors. We're going to block all those, right? That's an evolving list, by the way, but this leverages Amazon's security team information to block for you. There are trade-offs to these rules, right? So, you know, make sure that you're testing these before you go live, right? Or testing when you go live, really. In other words, you might want to test this in a non-production environment before you launch it for your production environment. Here's some other components to consider around WAF. So you got your managed rules, you got your own custom rules that you can create, and you've got automated rules that you can use with guard duty and security automations. Here's some other components, right? So the web ACL basically wraps around a bunch of rule groups, which have rule statements in them, right? In addition, you'll have something called an IP set. Where is this here? Yeah, IP set. So there's a rule group. There's also a regex set if you're using strings, so you're matching against strings. You can also specify logging, which can be CloudWatch and or Kinesis streams. Of course, they're your targets, the things you're standing in front of. The IP set, by the way, is a collection of IP ranges that you want it to use together in a rule statement. So like these could be like AWS resources, right? You can reference that set when you set up a web, like a rule like statement. So in other words, you can say, hey, these IP addresses are my corporate IP addresses, always allow them. These IP addresses are known bad actors that we've had trouble with in the past, always deny them, right? So IP sets, you can create these sets that can be referenced in rules. You can create a regex set that can be referenced in rules. So think of this as just interpolation if you're a programmer, right? Instead of having to define the IP addresses in every single rule, you can just say, hey, anything that's in IP rule set block, block it. If anything's in IP rule set corporate allow, you should allow it, right? So you can create these kind of like IP sets that you can then reference inside of your rule statements. Same with regex patterns, right? You might have regular like string evaluation patterns that you want to use. You can also like reference those in your rule sets, your rule statements as well. Rule statements, right, that are available like as part of a rule could like be pattern matching. It could be, you know, and ors like logical operators, filter traffic. You could rate limit, say, man, these people are going too fast. Let's slow them down. And then cross-site scripting, SQL injection, right? Manage rules from the marketplace. The WAF is actually really powerful. So, and by the way, you can nest rules inside of rules, right? For example, let's say that you're wanting to like limit requests from like a specific geographical area, like to control the rate of requests. You'd use like a rate-based rule, right? Like a traffic filtering rule, and then nest a geographic match rule, like a pattern match rule inside of it to narrow the scope of the rate tracking, right? So just so you know, not all rule statements are nestable, but like those kind of things are. So you say, look, I want to filter traffic, but only if it matches because it's from, you know, Sandovia, which I just made up. I don't even know if that's actually a country. So, and you can combine rule statements with the logical operators. So you can use and or statements or not this statements, like to combine rule statements together, right? There is a visual editor on the console for this. And so just know that it only supports a certain number, like amount of nesting. If you want to nest more, you're gonna have to write it in JSON yourself. You know, every console has limitations. Let's see. This is going to allow you to monitor web requests and ACLs using CloudWatch. And then you can like, if like a certain number of blocked reactions, like blocked requests show up over a certain period of time, you can throw an alarm. This alarm, there's a Goku health check. Did someone really just sneak that in there? They snuck a Goku health check in there, huh? Little Dragon Ball Z there for those of you who used to watch anime. So, basically what this does is that this alarm can actually trigger a response actually as well. So you can actually trigger CloudWatch to trigger an alarm, which could trigger CloudWatch events or SNS or a Lambda. So as an example, let's say the WAF, something shows up in the logs or a metric goes off, CloudWatch can trigger an alarm, which triggers a notification, which triggers a Lambda. That's one way to do it, which sends an email. I gotta say, this looks a little cumbersome to me. I don't know why you wouldn't just have SNS send you an email directly, but whatever. Maybe you need to fetch the logs, which then is why you have Lambda. But then I might still send it back to SNS. But I guess you could use a simple email service. It was like a bulk email, right? SES, the simple email service, is awesome at really bulk emails. So maybe that's it.
And this is probably into the weeds, but you could also just use the SES or SNS API inside Lambda, which is indirectly calling that, I suppose.
Yeah, that's what I was saying.
Yeah.
Yeah, I honestly, I'd probably just have the rule trigger a Lambda, have it fetch the logs, and you just invoke it to SNS. But that's just me, right?
Yeah.
I guess what this points is the extreme flexibility of how you can approach this. Yeah. Let's see. Here's a sample log. Notice that down here at the bottom. Let's highlight that for a second. My mouse is moving funny. That's weird. All right. So notice down here that there's a blocking action, right? Here's an allow action with some beta customers. Although health checkers, why would you block health checkers? Anyway, that's neither here nor there. And then notice that here's the default, right? Kind of rule. But here's a sample log. It's taking like a sample of the requests and kind of display the summary. So you can sample a log, right? So this is in the WAF console. And what you're doing is that if you have request sampling enabled, you can view a sample of the request with the associated resource, that the resource is forwarded to the WAF for inspection. So for each sample request, by the way, you can view details about the request, such as the originating IP address, as you can see there, the headers, the host name, any rules that it match, what was the request time, right? So you can also fetch this through APIs as well if you want to do health checks. All right. If you want to see the full logs, by the way, you do actually need to export them. So, this is going to typically require you to actually dump this into Firehose. It is JSON formatted. You can extract, obviously, information. From there, by the way, you can route it out to third parties. Notice that Splunk is listed there. Elasticsearch is listed there. You could also, by the way, dump it into like Elasticsearch and throw Kibana in front of it. Or, dump it into your favorite third party if you want to. You can actually set up EventBridge. Wait, is it EventBridge? Hold on. I think it's EventBridge. You can actually set it up for EventBridge so it can actually dump data into it. Like if you want to push it to a third-party resource like Datadog or something like that, EventBridge can do that for you as well. And then you can build dashboards. You could use, by the way, you could dump this into CloudWatch logs if you wanted to as well. That gets pretty expensive, just so you know, but you could. And then you could use CloudWatch dashboards to create your own dashboards. I think Kibana and Grafana and the other tools are better. But you may not want to go outside the ecosystem.
I think if you could use QuickSight, but then I think QuickSight, you'd have to have it in a RDS or DynamoDB for QuickSight.
Actually, if you had it in CloudWatch logs, you could get it from QuickSight, could read it.
Yeah, but if you didn't want the cost of CloudWatch,
You could dump it into a bucket.
yeah, okay,
Do
there
some
you go.
Athena with it if you wanted to. So as long as it's structured,
Yeah.
QuickSight could probably pick it up. Yeah. Here, by the way, is that security automation template that I was talking about before. Wow, that is a complicated diagram. Whew. So this is basically a template, and this is what this template does, right? This template allows you to like look at what's being blocked and the signals that are coming in from your application to basically automatically update WAF rules. That's what this is. This, you are not going to be asked this on the exam. Just know that you can automate the update of WAF rules using something like CloudFormation, right? So this, by the way, the sources for this could be a scanner and probe. It could be IP reputation lists. It could be a honeypot that you've set up with bad bots, right? In order to lure somebody in. You could also do it with guard duty, right? You do it with guard duty where it actually generates findings, they parse the findings, and then you can actually stick that as a new rule into your WAF. So, yeah. Notice, by the way, that it's actually persistently storing the bad known IP address in this case in a DynamoDB table. Okay. Good. All right. So the last two pieces we're going to cover are Shield Advanced and the Firewall Manager. So since it's already 1:27, I'm going to stop here and just pause because we would be a few minutes in and we would end up stopping anyway. Tomorrow, we're going to talk about securing your data. So a little bit more about data at rest instead of protecting and data at transit, but instead of like protecting the edge. And then we're going to talk about large scale data stores, migrating workloads. And then the last day, we're going to talk about, optimizing costs and pieces like that. We do have a lab tomorrow, much like we had a lab today. Just to check in with the last 3 minutes we have left. Ideally, you're going to be working these questions, the practice questions, again, until you're getting that 99 or 95 percentile. Does anyone have any questions for me, or how's that going, or anything that I should know about your current practice?
For the exams, do you know off the top of your head, and I can look it up if you don't, what percentage is roughly put to networking?
I don't know that they make a distinction, actually. Let's look that up. I don't think networking is one of the things they categorize against. Guide. Let's take a look, actually. So I don't think, if we look at the exam guide. Nice. Let's see here. Yeah, I don't think that like they call out networking specifically. I think that about a third of the exam is about design, right? Which, makes sense. Was there some specific networking question that they were like interested in?
No, I just noticed in I think the 20 questions I've done, when I kind of parse why am I making errors, it's either I'm not fully remembering all the little points and I'm like, oh, it's this, but it could have been that, but then I forget. Or it's like I just don't understand the networking concepts and all the little parts well enough. And it seems to be it's more on one end, it's user error for my interpretation. I'm like, oh, that's right. Another one, I'm like, I just don't even know. And it tends to be on the networking part where I don't know.
Yeah, so that they do want you to know how to design networks for complex organizations, as called out in the particular thing. What I might do, Brad, is do me a favor and bring that, if you find that question, bring that question. Because then we can like see like what parts maybe, because honestly, with any of you, you probably someone just needs to say it. This does this, this does this, this does this, and then that's probably be the end of the whole thing, right? But this is what they expect from you from a networking perspective, right? As far as design goes. So IP addressing strategies, DNS strategy, network traffic and security, and then connectivity needs for hybrid, and then a way to audit, which is very not about the fundamentals of networking, right? It's about all the ancillary concerns. So And then I don't think there's anything else in here around networking, if I remember correctly. It was all around deployment, migration, and whatnot, cost control. Notice there is no dedicated thing per se around security, but it is included in the design section, right? So, like for example, security requirements, right? But it's not like, it's like bundled in with everything around design for new solutions, right? So. Good. Other questions? Okay. So this is the end of 3 days. Oh, let me do this actually. Let me post up the playlist. I'm gonna post it in Basecamp as well, but I'm gonna post it here just so you can grab it really quick if you really, really want it. Oh, where are you? Here we go. Oh, that one had an arrow. Why did you have an arrow? Let's go figure out what's going on there. All right, so there's the playlist. I'm gonna post this in Basecamp immediately. I'm gonna go right over to Basecamp and post it in. So this playlist will have the videos attached to it. Most of them are still finishing HD processing, so you might see it just show deleted videos right now. Probably take another hour for it to finish all the high-end processing. But it should be there. There should be 2 videos there right now. There'll be a third there shortly. Okay, so. And they should say deleted, right? There should no videos because they're actually still finishing processing. So, yeah, but they're there. Google just needs to finish whatever Google is doing to YouTube is doing to it. Okay. All right. Anybody need anything else before I let you go? Okay. Good studying. Post in the Basecamp if you need assistance. I typically will respond pretty quickly if I'm awake. Otherwise, I'll just catch you tomorrow at 9 a.m. and we'll finish this out. Okay. And then we're meeting tomorrow and then we're going to meet on Monday. So please study over the weekend, but I'll talk more about that tomorrow. Okay. All right, everyone, have a good night or good day.
Yeah, bye all.